Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. So in this course, we are going to be looking at learning the Unity game engine. Okay, Unity is a game engine, which basically means it is a tool that we can use in order to create pretty much whatever sort of game we want to make. Okay, so let's look a bit at Unity. Now, Unity is a cross-platform game engine which is used by millions of people around the world. Okay, it is the most popular game engine, and more than half of the mobile games you see on the App Store were created using Unity. So, Unity also is very versatile, and this basically means that we can create any sort of game ranging from 3D to 2D, mobile, console, multiplayer, virtual reality, and even augmented reality games, okay? And along with all these different things that we can create, Unity also allows us to build to pretty much any platform you can think of, okay? Android, iOS, even if you want to build to Microsoft VR headsets, okay? Unity has the tools available to do that. Now, what are the goals for this course? Well, first of all, we want to learn the Unity editor, okay? This is a piece of software that we need to get accustomed to, and we also then need to look at all the different features that Unity has and that we can use in order to develop our games, okay? So we'll be looking at each of these individually so that by the time we reach the end of the course, you yourself are rather familiar with the engine and you're comfortable with using it. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Now let's get started with our first lesson. Hey everyone, and welcome. In this lesson, we are going to be looking at installing the Unity Hub. Now, this is basically a program which allows us to manage all of our different Unity projects as well as different versions of the Unity editor. So let's hop over to unity.com and look at how we can begin. So here I am at the unity.com website. And pretty much what we want to do is go down to where we have this blue download Unity button. Okay, we're going to click on that, and that is going to navigate us over to the downloads page. Now, you should see then a download button here. For me, it says download for Windows, but if you're on Mac, it should say, download for Mac OS. So I'm just going to click on that, and it is going to begin downloading the installer. Okay, and once that's done, we can open up the installer and begin setting it up. So, first of all, we just want to click on I agree. We then want to choose a location to install the Unity Hub to. Normally the default location is probably the best. Then click install, and that's going to begin the process of installing it. And once that is done, you should see we have the completed setup page right here. Make sure to enable Run Unity Hub, click finish, and we should then have the Unity Hub open up for us. Okay, and when the Unity Hub opens up, you may have this little pop-up appear. We're not going to install it this way because for some people it may not appear, so we're just going to click on Skip Installation at the bottom right here. And you'll see initially that we are at the installs page, okay? So if you're not here, you can go over to the left-hand side on the navigation panel and click on Installs right here. And this is basically where we are going to have all of the different versions of Unity installed for us, okay? Right now, of course, we have nothing, so let's install Unity. So I'm going to go over to the top right corner of the screen and click on the Install Editor button right here. And that is going to open up this window, okay? Now, what we want to do is we just want to find the most recent long-term support version of Unity, okay? So right now I've got 2021.3, which was released now in 2022, and you should see it says recommended version, okay? So find the recommended version, click on the install button here, and that is going to bring us over to the modules page. Now, Unity doesn't have all of the build platforms installed by default because it takes up quite a large amount of space. So if you do want to build to Android or iOS, you can enable them right here. Or later on, if you want to change your mind and you might think later on, okay, I want to build to Linux now, for example, you can come back to the Unity Hub and install the modules afterwards. Okay, we're not going to install any modules now, but we do need to make sure that we have Microsoft Visual Studio Community here enabled, because that is going to be the program we use in order to write our code. Okay, so we need that enabled, of course, and that is around 1.2 gigabytes in file size, and in total it should be around 6 gigabytes. Okay, so make sure you have enough space available for that, and we're going to click continue. We then need to accept the Visual Studio Community License terms and click install. Okay, and that is going to begin the process up here. Now, since it is around 6 gigabytes in size, it may take some time depending on your internet and computer speed. So wait for that to finish and then continue on with the next lesson where we look at actually creating ourselves our first project. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can create a new project inside of Unity. Okay, so let's go ahead and open up the Unity Hub. Now, inside of the Unity Hub here, in the previous lesson, we went over installing our version of Unity. So we have the editor now installed. Do make sure that is complete before you continue on with this lesson. Now, depending on the size of the editor, it may be a couple gigabytes. That can take quite some time, so do make sure that the editor or the install has completed. Now, what we can do is we can go over to the Projects tab right here at the top left corner. And inside of the Projects tab is where we have all of our different Unity projects listed out. Now, you can see I already have some right here, but for you, it will most likely be empty. So how do we go about actually creating a new project? Well, we want to go to the blue button at the top right corner, which says New Project. We'll click on that, and it's going to open up this window right here. Now, inside of this window, this is where we want to basically choose a template. Now, a template is sort of the way that Unity sets up the editor for us to use. The two main common ones are going to be 3D, which is already selected for me, and 2D, okay, because Unity can create both 3D and 2D games. So basically, if you want to create a 3D game, you click on the 3D template. If you want to create a 2D game, you can click on the 2D one here. Now, if, for example, you click on the 3D template, you open up the editor, you start making your project, and then you're like, I actually want to make this a 2D game. Well, Unity doesn't sort of like lock you off from doing that. Rather, all these templates are just Unity changing some settings that you can, of course, go ahead and change yourselves in the editor. So you can easily make a 2D game with the 3D template if you wish, but it's just a bit easier since Unity sets some stuff up for us already. Okay, so don't think of templates as different versions of Unity. More so, they are all the exact same version of Unity with just a little bit of different things done to them before we get to actually create our game. So I'm going to click on the 3D template right here. And then on the right-hand side, we can give our project a name. I'm going to call this one Intro to Unity. And then we can choose a location for this project, okay? And you can have a dedicated folder on one of your drives if you wish, or wherever you want. So once you have a name for your project and a location assigned, we can click Create Project, and that should close the Unity Hub and open up the editor. And after around a minute or two, the Unity editor should open up, and now we can begin creating our games. Hey everyone, in this lesson we are going to be looking at the Unity editor, and we are going to basically see how it works and how we can navigate around it. So let's look at the Unity editor. Okay, now upon creating a brand new Unity project, you're probably looking at this and being a bit overwhelmed, okay? There's lots of buttons, lots of different windows, lots of different inputs and all that, and probably a lot of names and labels that you don't really understand, and that's entirely fine, okay? In this lesson, we're going to go over each of these windows and basically see what they are and how do they serve us in creating games. So, when you open up Unity, you should have this default layout right here with these different windows visible. Now, what is a window? Well, in Unity's terminology, a window is basically like a little panel. As you can see here, there are these individual segmented rectangles, and each of them serve a different purpose. Okay, you can see over here we have a little tab which says its name. We have the hierarchy, we have scene, we have project, and we have inspector. And over here on scene, for example, you'll see that there is also a little other tab. It's a bit like a web browser where we can switch between two different tabs, scene and game. And game is basically where we'll be playing our game to test it out. Same thing for down here in the project window. We have project and then we have console, okay? So what are these windows? The hierarchy basically lists out all of the different objects that we have in our current scene, okay? You can see right now we have a scene name, which is sample scene, and we have two objects, okay? We've created a new Unity project and we are basically given a bare bones scene to contain our game. And we have a main camera, which is basically what our game is going to be rendering to, and a directional light. Now these two objects are here by default, and look what happens if I click on the main camera, for example. I'll click on it and you'll see a few things happen. First of all, over here in the scene window, okay, which is known as the scene view, we have the camera selected, okay? You can see over there, we have that camera selected and we have this weird looking thing on top of it, which we'll go over a bit later. And as well as it being selected in the scene view, we also have the inspector window over here changed quite a bit, okay? And now the inspector basically is listing out all of the different properties and components that this camera has, okay? So the hierarchy lists all of the different objects in our scene, and the inspector basically inspects whatever object we have currently selected, okay? So if I click on directional light, you'll see all of a sudden the inspector changes, and now we are looking at all of the properties on the directional light. And you can also see over here in the scene view that selection changes as well. So we've got the hierarchy where we can select our objects. We have the scene view, which is basically like us looking into our game world, where we can see all of our objects. And we have the inspector, which basically has a closer, more finer look at whatever object we have selected, so we can look at its different properties, and we can of course go ahead and modify them, okay? For example, if we want to make the camera's field of view larger or smaller, we can modify that property right here. Something else is that we can also select objects directly in the scene view. Now, it may be a bit hard, but you can see there is this little sun icon right here, and this sun icon is there to represent this directional light. Now, we can select that directional light by clicking on it inside of the hierarchy here, or we can go ahead and click on that little icon in the scene view, and that basically does the exact same thing, okay? We have the properties in the inspector, and we can modify them there. But what is the project window down here, okay? The project window or the project browser is basically the file explorer for our project. Whenever we created a new project for our game right here, what we have basically done is created a new folder somewhere on our computer. And that folder basically is going to contain all of the files and all of the assets that we'll be needing for our game, okay? So you can think of it like all of the textures, materials, 3D models, sprites, sound effects. Now, you can see by default, we have one folder here, okay? Our scenes folder. Now, what we can do is we can just double click on that folder to open it up. And when it opens up, you'll see that we have one file right here, okay? We can click on it, and you can see that is called sample scene.unity. Now, the way that Unity actually organizes itself is in what's known as a scene. And a scene is, you can think of it like a level, okay, where you have sort of your self-contained environment, and you can have multiple scenes which sort of act, yeah, like I said, as levels. And we'll go over that a bit later on. You can also navigate your project files over here on the left-hand side, where we can click back on our assets folder, which is the root folder. And we can also go ahead and create new folders. For example, we can right-click, go create folder. That will basically create us a new folder here. And if we wanted to import some sound effects, for example, we could open up a window, like a file explorer, and just drag them in, okay? Just drag them in here, and they will import. Now, also next to the project tab here is console. And the console window is basically there for us to see any sort of messages that the editor wants to tell us. So for example, if we're playing our game and there's some sort of error in our code or error in the way we set up an object, it will log a message to the console explaining what the issue is. And finally, we have the game window, okay? And the game window is basically where our game is going to be rendered, okay? What you see right now is basically what our main camera over here is seeing, okay? If we click over into the scene view, you can see our main camera over here. It's kind of hard to really understand what's going on because we don't really have any physical objects in our scene. But yeah, the game view is basically showing us what our main camera is seeing. And what we can then do is go up to the top here and click on the play button, okay? You'll see there are 3 buttons. We have the play button, the pause button, and the step button, okay? So if I click on the play button, that's going to basically gray out the editor a bit, and now our game is playing, okay? So if we would have objects, if we'd have some sort of controller, we'd be able to, play our game and test it out. You can click on the pause button here to pause it in case you want to pause an action in time to go change something or go check something. And then we have the play button to basically stop playing the game. And then when you're playing the game, you can click on the step button right here to basically go forward 1 frame at a time. But I don't really find myself using that function too often, okay? It's mainly just the play button and the pause button. So again, when you're in the play mode right here, you'll see that the screen has sort of gone a bit darker, and the play button is now blue. And if you click on the blue play button, it will stop playing the game. Now, something else I want to show you is the fact that the Unity editor is very customizable, okay? These aren't all the windows that you will be using. In fact, you can go up to here at the top, click on window, and you'll see here how many different types of windows there are. There's windows for animation, audio, AI, setting up UI and everything, okay? There's plenty of different windows, but how do we actually move them around? Okay, well, pretty much what we can do is just like with a window on your computer, you can click and drag on the sides to basically resize it, okay? So as you can see here, I can click on the edges of these windows to resize them. I can even, for example, click and hold on one of the tabs of the window here and drag it out, and it drags out into its own individual window. I can then go ahead and dock it. As you can see, it sort of automatically snaps wherever I'm dragging, so I can chuck the console up here. But for me, typically, I like to put the console next to the project window here, okay? So we have both the project browser and the console visible at all times. And I do like to make my inspector a bit wider just because there is a lot of information that we need to display. Okay, so that is a look at the Unity editor right here. Now, one more thing, and that is if your editor, if you're messing around with some windows and you accidentally close them, and you want to go back to the default. If you want to go back to the default layout, you want to go to the top right corner here where we have the layout drop down and just click on default, and that is going to swap you back to the default layout. But I'm going to get the layout that I like with the console over here on the side and the inspector window a bit wider, like so, and there we go. So feel free to explore the Unity editor, move around the windows, and get ready for the next lesson where we start looking at how we can actually navigate around our scene. So I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at scene navigation inside of Unity. Now, scene navigation is basically the way that we can control the scene camera in order to build our levels. So let's hop over to the Unity editor right now, and what we're going to do is we are going to be looking at this center scene window right here, okay, the scene viewport. Now, the scene viewport is basically our eyes into our game world, okay? We also have the game view right here. Now, the game view is a bit different. The game view is what our camera object here is seeing, okay? And this, in turn, is going to be what our game is going to look like when we press play. Whereas the scene view is basically a way for us to fly around, select objects, move them around, and just overall build and construct and modify our levels, okay, here in the editor. So how do we actually do all of that? Well, first things first, what we can do is if we have our mouse over the scene view, what we can do is we can hold down right mouse button, and you should see that your mouse cursor turns to this little eyeball icon. And what we can then do is we can just look around as if we are playing a game, okay? So we can hold right mouse, look left, up, down, and right. Okay, so it's pretty cool that way. So we can look around. Now, what about moving? Well, if we hold down right mouse and we are looking around like so, while we are doing that, we can use the W, A, S, and D keys to fly around. Okay, so W to go forward, S to go back, A to go left, and D to go right. We can also move vertically, so if we press E, we can go up, and Q to go down. So using those 6 buttons, we can basically fly around our scene here, and as you can see, we don't really have much to look at, so what I'm going to do is I'm just going to quickly add in a new object, and that is going to be a cube. So the way we can do that is by going over to our hierarchy right here, and you'll see at the top left of the hierarchy window, there is a little plus. So I'm going to click on that, and this is basically where we can create all different types of objects for Unity. So I'm going to go over 3D object and I'm going to click on cube, and that is going to create a brand new cube in our scene right here. You'll see it pops up in the hierarchy. We can select it. You can also see that with 3D models inside of Unity, in the scene view, they have a little orange outline whenever we have them selected, and we have all the details here inside of the inspector. So we have our cube there just as a bit of a reference for us to see when we're flying around. Now, what happens if you are, let's just say, on the other side of your map working on something, and you're like, all right, I want to go back to the cube. Well, you could, of course, hold down right mouse and fly over there, but a much quicker way is if you know what the object is that you want to go to, you can select it here in the hierarchy, okay, you'll see it's highlighted blue, and then you can press F on your keyboard, and that is going to focus in on the object, okay? So we could be over here, press F, once we have an object selected, and we'll focus in on it. I can select our main camera now, press F, and we'll focus in on the main camera. Same thing for the directional light. Now, while we've been doing this, you've probably noticed that we have this little gizmo at the top right corner of our scene view, okay? And it sort of rotates whenever we look around. Now, this is what we call the scene view orientation gizmo, okay? And this basically allows us to quickly orientate the camera along certain planes of view. So let's just say we wanted to have a bird's eye view of our level, okay? We could, of course, fly up, look down, but, it's not exactly 90 degrees down to the ground. So what we can instead do is click on the green sort of arrow here, the green little nozzle. We can click on that, and it is going to automatically put our camera in the air and point us down. We can then click on the red one for the X orientation, and that is going to have us in a side view. Same thing for the blue one for the other side. And we can basically just flip our camera around these different directions. Now, also what we can do is click on the center square. And what this center square does is it changes the perspective view of our camera, okay? Because right now our camera is working like every other camera in the world, which basically captures depth, okay? You can see if we look at the cube here, the further away from the cube we go, the smaller it gets, okay? That makes sense. But what this little button does is it can toggle our view to, instead of being perspective view, we can turn our view into orthographic. So if we click on this little cube here, as you can see, all of a sudden our view has changed and we have this sort of view now, which basically makes it so that there is no depth, okay? No matter how far away an object is, it will always remain the same size. Now, when might you want to use this? Well, typically you'd use this for 2D games because 2D games don't really have depth per se. Or if you are maybe constructing some things in your level and you want really fine adjustments and you don't want perspective and depth to get in the way of that, you can of course toggle the orthographic mode in order to get this. And also what you can then do is hold down middle mouse to sort of drag the camera around whatever plane your camera is facing. So for example, if I'm on this rotation, I go hold down middle mouse and drag, and it sort of just pans the camera left, right, up, and down, okay? So we can then click that cube again to go back into perspective mode and bring back our depth like so. And yeah, that is just a few of the controls that we can use here inside of the Unity scene view to navigate around, okay? Once more, we can hold down the right mouse button to look around, While we are holding right mouse button, we can also use the W, A, S, and D keys to fly around, like in a video game. And then we can also use the E and the Q keys to move up and down. We can also hold and drag middle mouse to sort of pan the screen around like so. And we then have the orientation gizmo over at the top right corner, which allows us to change the orientation of the camera as well as the perspective, okay, like so. And finally, if we have an object selected, we can press F on our keyboard to focus in on them. So yeah, mess around with those, get comfortable with the controls, and in the next lesson, we are going to be looking at the concept of game objects. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at game objects. Now, let's hop over to Unity and begin learning what these things are. So, with Unity, game objects are what you could call the fundamental building blocks of games, okay? Game objects are what make up all of the different entities inside of your game, okay? Everything from the lights to the cameras to the player to the 3D models of the rocks and trees, the environment itself, and everything you can interact with is a game object, okay? Now, that's quite a abstract view of what they are. So let's have a look at some examples. So in our scene here already, when we create our new project, you'll see that in the hierarchy here, we have a main camera and a directional light, okay? And these are what are known as game objects, okay? We have a main camera game object and a directional light game object. The main camera is in charge of rendering what it sees to our screen, and the directional light is in charge of illuminating the environment. Now, if you click on these objects, you'll see that in the inspector, we can see their properties, and they are sort of divided up into these individual little sections, okay? You can see if we select our directional light, you see we have this little section here called transform, which we can sort of toggle open and close, as well as light. Now, these are what are known as components, and components are what give game objects their individual gameplay behaviors, okay? At its core, a main camera and a directional light are the exact same thing. They are a game object with a name and the ability to enable it or disable it. But what makes them individual is the different components that we assign to them. You'll see that on our main camera and our directional light, they both have a transform component, okay? And every single game object has the transform component by default, and it must have it, okay? A transform component is basically the fundamental foundational component that is required, and this basically gives that object a position, rotation, and scale in 3D space. And then from there, we can add a light component, for example, to have this object illuminate stuff, which is what our directional light does. Or in the case of our main camera, we can add a camera component, which renders whatever it sees to our screen, and an audio listener component, which allows it to hear sounds. Now, let's look at some different types of game objects. What I'm going to do is I'm going to go over to the hierarchy here, and I'm going to click on this little plus icon, okay? And this allows us to create a number of different game objects, okay? You can see 3D objects, we have stuff like cubes, spheres, capsules. Effects, we have particle systems, trails. Lights, we have all our different types of lights. Audio, video, UI. There's tons of game objects inside of Unity and even more components. So what I'm going to do is I'm going to go over to 3D object, and I'm going to create ourselves, let's just say a sphere, okay? You'll see here, what happens is when we create an object, it gets added to the hierarchy, and we can actually give it a name. So I could call it something like my new sphere. Press enter to assign the name. You can see the name does also change in the inspector here, which we can of course click to modify at any time. Now this sphere, if we select it, you can see over here in the scene view, it is highlighted and it is selected. So over in the inspector, we have the list of components which make up and basically define this sphere object. So of course we have the transform component, which gives it a position, rotation, and scale in 3D space. That is a requirement. But you'll also see that we have 3 other components, and these 3 components are there by default. You can remove them, you can add more as well. For example, the mesh filter component, this basically just defines which 3D model this sphere or this game object is going to be rendering. So if we click on the little circle next to this property here, what we can do is change it to a cube, for example. And you can see here that our object is now cube, but let's change it back to a sphere. So that's what the mesh filter does. Then we have the mesh renderer, and this basically defines all of the settings for rendering it to our screen, okay? So what material is it going to have? Is it going to cast shadows? Is it going to receive shadows? And a bunch of other lighting related settings. And then finally, we have the sphere collider component, and the sphere collider component basically makes this object solid, okay? So if we would have physics, or if our player was running around our level, they would basically hit this object and not be able to pass through it. So that is generally how a 3D model is composed with components, okay? And you can see how it differs from our directional light, for example, okay? They look totally different here in the scene view, and the sphere, of course, has a physical representation. They all are fundamentally the same thing. They are all game objects. The only difference is the components that we assign to them. And to show that even more, I can click on our sphere here, for example. We can go down to the Add Component button right at the bottom here. And the Add Component button, if we click on it, it allows us to go ahead and basically add a new component to this game object. So we can scroll through the list here, we can click Open, and you can see if we keep just having a look at these different things, there are lots and lots of different components to attach, okay? So let's just say on our sphere here, we want it to emit light. What we can do is we can just go to the search bar here and type in light. And you'll see here we have the light component. We can click on that. And now it may be a bit hard to see just because we don't really have a floor or any other environment, but our sphere is now emitting light, just like the directional light is. So you can see that we can just attach pretty much whatever components we wish to any game object, okay? If we want our sphere to be able to emit light, we can. If we want our sphere to have physics, we can attach a rigid body component. If for some reason you wanted your directional light here to have a collider, we could of course go Add Component, look for a sphere collider, and attach it like so, okay? And you can see we have this green outline of the sphere collider. Now how about removing components? Because you probably don't want a collider on your directional light. So what we can do is we can go over to the inspector, and you can see that there are these 3 little dots next to the component. So we can click on those and just go Remove Component, okay? If we want to remove the light on our sphere, we can do that. Or to make it a bit faster, we can just right click on the component header here and go Remove Component. And there we go. So that is a quick look at game objects inside of Unity and how they are basically made up of by components, okay? Game objects are the building blocks of every single object and entity in your game, and the components are what make those game objects individual and give them their gameplay behaviors. Thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be looking at how we can move our game objects. Okay, so we're able to create them, we know what they are, but how do we actually move them around our scene to place them where we want them to? Well, first of all, we need to look at Unity's coordinate system, okay? Now, what is a coordinate system? Well, a coordinate system is necessary in order to pinpoint a specific position in 3D space, okay? We have a game object in our scene. Where is it? Okay, how do we define its position in our scene? Well, we do that with an X, Y, and Z value. Just like if you were to plot a graph, you need a horizontal and a vertical axis. Yet in 3D space, we have 3 different dimensions, so we need 3 axes in order to position correctly an object in 3D space. Okay, an X, a Y, and a Z value. Now, let's hop over to Unity and have a look at how we can do this. So if we select our main camera, for example, here in the hierarchy, you'll see that over in the inspector, over in our transform component, we have a position property, okay? And the position basically defines the X, the Y, and the Z axis, okay? And altogether, that is our position, okay? Now, look what happens if I change, for example, the X axis here to 1. You can see that our camera has now moved. We can go to -1 and it moves back, okay? If I change the Y to something like 3, you can see the camera moves up. Now, let's go ahead and create ourselves a game object. So what I'm going to do is I'm going to right click in the hierarchy here, and I'm going to go 3D object, cube. Okay, I've created ourselves a new cube right here. You'll see that we have this 3-arrowed little overlay, and this actually looks similar to the diagram we had just in the slides. And this is what's known as the move gizmo, okay? And this basically allows us to move our object around. And you'll see that there are 3 different arrows, okay? The green arrow is basically for the Y-axis, so that goes up and down. The blue is for the Z, that moves forward and back. And the green and the red arrow is for the X-axis, and that moves us left and right. Now, look what happens if I click and drag on the blue arrow. You can see it gets highlighted in yellow, and I can drag it along the Z-axis. And if you look in the inspector while I'm doing this, you can see that the Z value of our position is changing, okay? It's in the negatives, and then we can bring it over into the positives if I drag it a bit further along. Also for the Y, we can do that as well. We can click and drag, and for the X-axis, we can do the exact same. So yeah, that is how we can move an object along its individual axes, like so. We can also go ahead and modify that directly, so I can set the X-axis in the inspector to be 0. It's going to move it over there. So if you want more precise numbers, you can do it that way. Also, in the inspector, you can hover over the individual axis headers. So if I hover over X, you'll see this little icon pops up over my mouse. I can click and drag to sort of adjust it here as well. Okay, so you can quickly adjust it just by using the inspector. Let's just say you just want to move your object along a flat surface. Well, you'll see on our object here, we have these 3 different little squares. Now, if I click and drag on the bottom one here, you can see that I'm moving the object along both the X and the Z axis. Okay, so we're moving along a single plane of direction. We can do the exact same thing for this red one. This moves us along the Y and the Z plane. And finally, the blue one, which moves us along the X and the Y plane. So yeah, those are just a number of different tools that we can use in order to position and move our game objects around in our 3D world. Now, what I'm also going to do is I'm going to right click in the hierarchy, and I'm going to create a 3D object sphere, and we can then move these objects along and just experiment with positioning them in our scene. Now, one more thing, and that is how can we delete objects? Okay, let's just say we don't want our sphere anymore. How do we get rid of it? Well, what we can do is we can go to the hierarchy, right click on our sphere game object, and then go down to delete, okay? We can also do Control Z or Command Z if you're on a Mac in order to undo your actions, or we could just click on the object and press the delete key on our keyboard, okay? So there we go. Now, in the next lesson, we are going to continue looking at how we can orientate and move these objects around by looking at how we can begin to rotate our game objects, okay? So we've looked at moving them around, but how about rotating them? Well, we'll be exploring that in the next lesson. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can rotate objects inside of Unity. So in the previous lesson, we looked at how we can move objects around along the X, Y, and Z positions. Now, in this lesson, we're going to be looking at how we can rotate them. So what I'm going to do is I'm going to create ourselves a new object. So I'm going to right click in the hierarchy, go 3D object, cube, to create a brand new cube right here. And to get over from the move tool to the rotate tool, what we can do is go into the left-hand side of the scene view, and you'll see there is a rotate tool button right here. We just want to click on that, and it will change. Now you'll see we now have a different gizmo appearing above our cube. And it looks a bit similar, okay? We still have the exact same colored identifiers like we had with the move tool. We have the blue here for the Z-axis, we have the red here for the X-axis, and the green for the Y-axis. Now, if I click and drag on one of these rings, you'll see that we can rotate this object around the Y-axis, for example, and you can see in the inspector that value is also changing. Now, in the inspector, this rotation value is in terms of degrees. So if I put the Y at 0, that is going to be 0 degrees along the Y-axis. If I set this to 90, it is going to be a 90-degree turn. So that's why the cube doesn't look much different. Whereas if I put it at 45 degrees, you can see one of the edges is on a bit of an angle. Now we can also rotate it along the x-axis by clicking and dragging on the red, and we can do the exact same by clicking on the blue to rotate it around the z-axis, okay, just like so. And of course, you can manually assign a rotation, so we can click and drag on the little X text right here in order to rotate it smoothly, like so, or we can go in and manually assign a value, something like that. Now, also with the rotation tool right here, we can just click in the middle. So if you're not hovering over any specific line, you can just click in the middle and it will sort of free rotate around your mouse. Now, this isn't very precise, but if you just want to get a sort of random rotation on an object, you can just click and drag, move it around a bit, and then you can get a random rotation, something like that. Okay, I'm just going to undo this with Control Z. There we go, back to 0, 0, 0. And you can also see that there is a white circle surrounding it. It might be a bit hard to see, but there is a white circle surrounding all the others. And if we click and drag on that, it will rotate this object relative to where our camera is facing. Now, something else that we'll probably want to go over is the idea of world space versus local space. So let's just say I rotate this object a bit, like so. Okay, so we have it on a bit of an angle. And then I go over and press W as a shortcut for the move tool. Okay, you can also press E to toggle on the rotate tool. So E for rotate tool, W for move tool. You'll see that our move tool has now rotated along with the cube. Okay, the green arrow, which is our Y, our up and down, is not facing vertical anymore. It is now facing vertical relative to the cube's rotation. So if I go back to press E and rotate it a bit more in this direction and maybe a bit in this, press W, you'll see that our move tool is now orientated relative to the cube, okay? And we can of course click and drag to move it along that relative direction. Now, this can be great for some instances, okay, if you want to rotate an object and move it along its relative directions, but other times you might want to still move it in terms of the global direction, okay, the globally defined up, the globally defined right, and forward. Well, to change between the two, we can go to the top left corner of our scene view window and click on this second drop down where we can switch between global and local. Okay, right now we're on local, so our tools are going to be positioned and rotated relative to whatever object we are on. Whereas if we click global, the gizmos are going to be relative to the world. Okay, they're going to be based on world space rather than local space. So now we can move this rotated object along like so. We can also rotate it a bit more, and you see that the move tool does not change orientation. Okay, it sticks into its original direction and we can move it around just like before. Now, also note that if you are modifying the position values, the position values here in the inspector are always in global space. So for example, if I were to move along the Z axis with the move tool, you can see I'm moving along this direction here. But if I modify the Z axis in the inspector, you can see that we move along the global Z axis, okay? So yeah, that is a look at rotating and also a look at the local and global space inside of Unity. And we'll be looking at the local and global space a bit more in detail later on once we start looking at what's known as parenting. But for now, this is the rotation tool. We can press E as a hotkey to it, or we can click on it here in the scene view. And we can rotate our objects around to whatever orientation we wish. Now, in the next lesson, we're going to finish this off by looking at how we can change the scale or the size of our game objects inside of Unity. So I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at scaling game objects inside of Unity. So here in the editor, what I'm going to do is I'm going to create ourselves a brand new cube. And with this cube, what we can do is we can go over to the scene view here on the left-hand side and click on the scale tool right here. Okay, and this is going to toggle it. Now, it looks a lot like the move tool, yet you can see instead of arrows, we have little cubes at the end. And if we click and drag on them, they are going to change the scale of our object in the inspector. You can see that's happening along the Z axis here, same thing for the X, and for the Y. Now, scale basically defines the size of the object, okay? Unlike rotation and position, so if I set the position to 0, 0, 0, and the rotation to 0, 0, 0, you'll see that our position is in the center of the world and our rotation is not rotated. Yet if I set the scale to be 0, 0, 0, you'll see that it doesn't exist, and that's because the default scale is not 0, rather it is 1, okay? And I think a good way of thinking of scale is in terms of percentages. You can think of the default 1 scale as 100% of its own size, okay? Because whatever 3D model, whatever sprite or effect you might have as the game object, that is going to be 100% of its normal size. So 1 is the default. And if I were to change it to be 2, then that means that this object is now twice as large, okay? Instead of being 1 size, it is now 2 size. We can bring that up to 5, and it is now 5 times as large. So scale does differ in that way, but apart from that, it behaves in pretty much the exact same way, okay? Just like when we can press W to go to the move tool, E to go to the rotate tool, we can also press R for the scaling tool, okay? And we can also click on this little cube in the middle of the tool right here, and this is going to basically scale up all of the axes uniformly, okay? As you can see here. Now, over in the inspector, we can of course modify these values individually as well. So if we want to make this cube half its normal size, we can go 0.5 on each of these X, Y, and Z axes. Now, you also see that there is this little icon next to the scale property. And what this does is it basically enables proportional modifying of these values. So if I click on it and then change the value of one of them, you can see they all change as well. Whereas if I disable it, we can also then go ahead and just modify individual axes. Because generally when you're scaling objects, you probably want to scale it along all of the axes uniformly. For example, you might have a 3D model of a tree. Now, you don't want to scale the tree along its x-axis, okay? Otherwise it would be very wide. And you probably don't want to scale it along its y-axis, otherwise it'd be stretched out. Rather, you'd probably want to scale your 3D models along all of the axes so that they maintain their proportions, okay? So yeah, bring this back to 1 here. So now that we have an idea of the movement, rotation, and scaling tools, I think it's time for a bit of a challenge. So this is the challenge that I want you to complete, okay? Using the move, rotate, and scale tools, I want you to create a stick figure as you can see here in this image, okay? It is constructed using a number of different cubes as well as a sphere for the head. So you'll be needing to create these game objects, you'll be needing to move them around, you'll also be needing to scale and rotate them as well to get them in the correct orientation and size that you wish. So have a go at the challenge and I'll be right back to see how you're done. Okay, so I hope you had a go at the challenge. Let's hop over back into Unity and have a look at how we can complete it. So first of all, we need to create our objects. So I'm going to right click on the hierarchy. I'm going to go 3D object cube. Okay, so we have our cube right here. What I'm going to do is I'm going to move it up here a bit. I'm also then going to press R to toggle the rotate, to toggle the scaling tool, and I'm just going to scale it up along the y-axis right here, okay? And this is going to be our main body. So I'm going to move that up like so. I'm then going to create another cube, but it's going to be a bit of a hassle to go ahead, create another cube, position it, rotate it, scale it. Instead, what we can do is duplicate this selected object. So with an object selected, I'm going to go Control D, and that is going to make a copy of it, as you can see. So then I can just move it over here. I can scale it down a bit, rotate it for the leg, like so. Duplicate that again, rotate it the other direction, move it over like that. Then for the arms, I'm going to duplicate the body here. I'm going to rotate it along like so, You can then also scale it down a bit, stretch it out a bit, move it up. And then what we can do is create the head. And for the head, we're just going to be creating a sphere. So I'll create a sphere like this, move it over into position. Probably need to scale it up uniformly quite a bit. And there we go. So now we have ourselves our stick figure like so. Okay, it's got its head, it's got its arms, it's got its legs, its body. And we've done this using both the rotation, movement, and scaling tools. Okay, so have a go at this, create some other stuff as well, just so you get used to the workflow of being able to move, position them. And also if you want more finer rotations, we can go over, for example, the arms here, they might not be exactly straight. So I can go over to the inspector and change the Z rotation. You can see we got an extra 0.55. I'm just going to make it -90 exactly, and there we go. So yeah, go through, create some other models if you wish. And in the next lesson, we are going to be going over the concept of parenting game objects inside of Unity. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at parenting inside of Unity. Now, also known as object parenting, this involves two terminologies, parent and child. Now, the way parenting works is that you have a parent object which can have children objects, and these children objects inherit the position, rotation, and scale of their parent. So let's hop over into Unity right now and have a look at how we can set this up. So as an example, let's go ahead and create a brand new game object. So I'm going to go over to the hierarchy, I'm going to right click, down to 3D object, and I'm going to create a capsule, okay, something like this. Now we can select the capsule, and over in the inspector we can change the name of it to be, let's just say, player, okay. This is going to be our player object for this example. Then down in position, let's set the position to be 0 on the X, 0 on the Y, and 0 on the Z, just so it's a bit more organized. Now we have our player here, right, and we can move it around like so. Now let's just say our player wants to be holding an item. This might be a piece of clothing, it might be a weapon, it could be anything that we want to sort of attach to our player. Well, for this, we can of course create another game object. So I'm going to right click on the hierarchy, go 3D object, cube, and let's rename this to be item. Now I'm going to position this as well as 0, 0, 0, move it forward a bit. I'm going to scale it down, let's just say to 0.5 for the scale, and just position it sort of like this, right? So we have our player, we have them holding or wearing an item. Now, of course, we'd want to move our player around. So we can select our player, move them around, but as you can see, the item doesn't move as well. So what we could do is, we could move the player, then move the item, but that's quite convoluted. So a way we can make it so the item follows the player is by making the item a child of the player. Okay, so how do we do that? Well, what I'm going to do is I'm going to select our item. I'm going to click and hold so that our mouse cursor changes like so. I'm then going to hover over player and let go. Okay, we're basically dragging item into player. And as you can see, something here in the hierarchy changed. Item is now indented and it is now a child of player. You can see on player it has this little drop down arrow which we can toggle to basically show and hide all of its children objects. So the item is now a child of player. So if we select the player and we start moving it around, you will see that the item basically sticks to the player, okay? It is inheriting its position. Now we can also go ahead and rotate the player, and as you can see, that cube is also rotating along with our player as if it is stuck to it. And just like with rotation and movement, we can also scale it as well, and that will scale up proportionally too. Now, how is this working and what is going on? Well, pretty much the item object, it knows that its parent is the player. So basically it sets its position to be whatever the player's position is, plus whatever offset we set here in the transform component. Okay, you can see here that the offset on the X is 0, the offset on the Y is about 0.26, and Z 0.52. Now, look what happens if I select our player and I move it all the way over here. Okay, you can see the X is like 14 and negative 11 on the Z. But if I select the item, you'll see that its X position is still 0 and the Z is only 0.5, even though we are pretty far away from the 0, 0 point in our world. And that is because this transform component is not showing its position relative to the world. Okay, it's not showing the global position, rather it is showing us the item's local position relative to the player. Okay, it is 0 units away from the player's X, and it is 0.268 units away from the player's Y origin. Okay, so whenever you have a child object, the transform component is not showing you the global values for the position, rotation, and scale. Rather, it is showing you the local values that are relative to whatever the parent object is. So if I go ahead and rotate our player around like so and scale it up a bit, you'll see that the item still has 0, 0, 0 on the rotation because relative to the player itself, it hasn't rotated at all. And the scale is still 0.5 because relative to the player scale, our cube is still half its normal size. Okay. Now, that may take some time to get used to, understanding how object parenting works inside of Unity, but it's something that you'll be using so often that over time it'll just start to click. Okay. Now, something else I think we should go over, and that is the idea of an empty game object. Now, to do this, we can just right click and go create empty. And an empty game object is pretty much what it sounds like. It is basically a game object with no components. Oh, well, we do have the transform component, but that is a necessity for everything. But there is no other components, okay? There's nothing defining what this is. And an empty game object can generally be used as the parent object for a lot of things. I generally like to use a parent game object for my player and then have the 3D model as a child, have the camera as a child, and any other items that we want the player to be holding as a child of that. Okay, I just prefer that for organization and it's generally a good workflow. Okay, so as a bit of a challenge, what I want you to do is I want you to create a sword which we can move, rotate, and scale with it all being a single unit, okay? So in this case, what we would do is we would probably have an empty game object, and as a child of that, we would have a number of different 3D models, which represents the sword, as you can see here in the image. And then by clicking on that parent, we should be able to move it around, rotate it, and it should basically act as an item that our player could use. So have a go at that challenge, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Let's go ahead and look at how we can accomplish it. So, over inside of Unity, what I'm going to do is I'm going to start off by creating ourselves an empty game object to sort of act as the parent, okay? Now, the reason why we're doing this is because this also allows us to decide where the origin or the pivot point for our object is. So I'm going to right click, go create empty, and I'm going to call this one our sword. Let's bring it over to 0, 0, 0 just to make it nice and organized here. And what I'm going to do is I am then going to right click on the sword. Okay, as a bit of a shortcut, we can right click on the sword object here in the hierarchy, go 3D object, cube, and that will create a cube and automatically make it a child of sword. Now, with this cube, we can resize it a bit, and I'm going to make this the handle, okay? We can then duplicate that cube with Control D. We might then drag it out a bit like so. Move it up here. Okay, and then for the blade, we can just duplicate this once more, drag it up, scale it up a bit, like so, and there we go. Okay, so we have a very basic sword right here. Now, what we can then do is select the sword parent object here, and as you can see, where the move tool is that's basically what's known as the origin or the pivot point for this object, okay? So whenever we move it, it is going to have that as the origin point for where the location is, and we rotate around that point as well. So we could then, have it as our player's weapon and then swing it around like so. And you'll see how all of the children objects follow along in suit. Now, something else I want to go over before we continue, and that is understanding that objects can have pretty much as many children as they wish, and those children can also have children, okay? So it's a hierarchy in a sense. So what we could do is we could go ahead, create our 3D object capsule once more, okay? Bring that over to 000. Let's call this one player. And what we can then do is drag the sword in as a child of player. Set the sword's position to be 0, maybe move it over here a bit, rotate it like so, and there we go. Our player is now holding a sword. It's pretty big, but there you go. And you'll see in the hierarchy that our player is the parent of the sword, and the sword is the parent of the 3 cube objects, okay? So you can basically make this tree of parent-child relationships that pretty much extend as far as you need, okay? And this sword then might have some sort of, magical effect that you might want to attach to specifically the blade and then have that as a child of the cube. And yeah, you can get into a lot of detail and have a lot of children objects of parents. Yeah, you'll definitely be going over this quite a bit when creating your games, as generally parenting is something that is used in many, many circumstances. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson, we are going to be looking at materials inside of Unity. Now, what is a material? Well, basically, materials define how an object is rendered to your screen, okay? The color of the object, the texture, the roughness, how metallic it is, and how it reacts to light. And there are many different other things that materials can do. If ever you've played a game, you would of course noticed that there are many different types of surfaces, okay? You may have water, which is slightly transparent, and it might reflect some of the light. You might have a tree, which is rough with a bark texture. Those are all materials, and those are defined by the game developers in order to tell your computer or your console how those objects should be rendered to your screen. So let's hop over into Unity right now and have a look at how we can create some materials. So here inside of Unity, what I'm going to do is I'm going to start off by just creating a brand new sphere game object. So I'm going to right click on the hierarchy, go 3D object, sphere, okay? And what you'll notice is this sphere has a pretty bland appearance, okay? It's white. You can see that the directional light over here is basically casting a light on the sphere. So it's very bright here and dark over here, okay? If we look at the directional light, you'll see the direction it's pointing with the blue arrow. And what we can actually do is on our directional light, we can go to the inspector and click on this little selection box here to basically enable and disable the light. And you'll see if I disable it, the lighting disappears. So by default, this sphere has a very simple material where it reacts to the light and it has a smooth white finish. So how can we create our own material? Well, down here in the project browser, what I'm going to do is I'm going to right click, I'm going to go up to create, and then over to material down here, okay? And I'm going to call this one, we'll just call it my material. Now, you'll see that when we create a material here, this is basically creating a new asset inside of our project, okay? This is now a file on our computer and we can use it in Unity here. So we have our material. Now let's click on it with left mouse, and you'll notice that over in the inspector, we have a lot of basically properties available to us, okay? And this is where we can modify the material. So you'll see we have things like albedo, metallic, smoothness, normal map, height map. Now there is a lot of stuff here to experiment with, but really we are only going to be focusing on the albedo and the metallic and smoothness, okay? Albedo is basically what color this material is. So if we click on this white box here, it's going to open up a little color wheel. So we can make it a red color, for example, and you'll see down here in the little preview window, we can click and drag on this to increase it in size. We have a preview of what our material looks like. So we have this red material, but how do we actually apply it to our sphere? Well, that's pretty easy. All we have to do is click and drag on the material in the project browser, and hover over our sphere and let go. Okay, we're basically just clicking and dragging it on. And now our sphere has that material. And something else that's pretty cool is anything we do to this material file right here, those changes will automatically be updated to our sphere. So let's just say we want to up the smoothness a bit. We can click and drag on this smoothness slider and bring that to 1. Okay, and you'll see right now our sphere is very reflective and it's reflecting the skybox in the background. Or if we want it to be a rough surface, maybe this is like some stone or wood, we can bring that down to 0 and it becomes a very non-reflective surface. Now, as well as smoothness, we also have metallic, which basically defines, how metal-like this object is. I'm just going to put that on 0. And something else we can also do is change the transparency of this object, okay? Because right now this is an opaque material, and you can see here, if we select our material, you'll see that we have the rendering mode set to opaque, okay? And opaque basically means it is a solid object. Well, if we click on opaque, you'll see there are a number of different rendering modes that we can choose. We have cutout, fade, and transparent. Now, if we want to be able to see through this object, we can select transparent, for example. And you'll notice that nothing really changes here. But if we click on the albedo color once more, okay, we can of course change the color just like before. But now what we can also do is go down to these 4 values, okay? And you'll see here we have the color wheel, and then we have the values RGBA. Okay, we have the red channel, which defines how red this object is. We have green and blue. And you'll see that when I change the color, those red, green, and blue values will change as well. And with those 3, that is basically how we can define colors. Now, how do we make it transparent? Well, we have one final channel here called the alpha channel, and that defines transparency. If we click and drag on this, you'll see that the sphere is becoming more see-through as I drag that down, okay? So full opaqueness at 255, and if I bring that down to 0, it's invisible, although with the transparency render mode, it does appear slightly, okay? But yeah, that is how we can use transparency inside of our materials. Okay, so as a bit of a challenge, I want you to complete these 3 materials that you can see on screen, okay? We have a reflective red material, we have a very rough blue material, and then we have a transparent green material. So yeah, have a go at that challenge, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Now let's hop over back into Unity and have a look at how we can create these 3 materials. So first up, what I'm going to do is I'm going to create our 3 spheres. So in the hierarchy, I'm just going to right click, go 3D object, sphere. I'm then going to go Control D to duplicate it and move 2 over like so, all right? Now down here in the project window, what I'm going to do is I'm going to right click, I'm going to create a new material. I'm going to call this one our shiny red. I'm going to click and drag it on our sphere like so, okay? And by default, the material that you create is going to be this white material. So it does not look like we're applying anything, but we are. So we can click on that shiny red material, go over to the inspector. We can change the albedo color to be red, and we can then up the smoothness value, okay? So it is now very reflective. So that's how we can create the shiny red material. Now, how about the rough blue? Well, let's create a new material here. I'm going to call this one rough blue. I'm going to drag it onto the middle sphere. And then for this one, I'm going to change the albedo color to be a blue color like so. And I'm going to bring the smoothness value down to 0, okay? So now it's pretty much not reflecting anything whatsoever, unlike the red one over here. And then finally, we have the transparent green color. So I'm going to create a new material. I'm going to call this one see-through green. And then we can drag that on like so. Now for this one, I'm going to set the albedo to be green. I'm going to bring the smoothness down to 0 as well. And over in rendering mode, we can switch this over to transparent. Click on the albedo color once more, and we're going to bring the alpha channel down to about halfway, okay? And there we go. So if we actually move over a bit, we can see the blue through the green as well. So we know that it is working correctly. So yeah, that is how we can create these three materials inside of Unity using Unity's material system. Pretty much what we're doing is we're going down to our project browser. We are creating a new file, which is a .mat file, which is material. We are applying some changes to the list of properties here, and then we are dragging that on to an object that we want to assign. Now, a way we can also assign a material is if we click on an object, okay, and if it has a mesh renderer component, that means we can assign a material. So over here, you'll see that we have a materials dropdown. If I click on that, and we can see the material that has been assigned, okay, the rough blue. Now, we can also then click and drag on a material and drag that into the property here, okay? So if you don't want to drag that onto the object itself, or if you've selected an object that you're not sure exactly where it is, but you want to assign a material, you can just do that over in the mesh renderer component, okay? Click and drag into the materials property right here. Alternatively, you can also click on the little circle next to the material property to open up a window which basically shows you all of the materials available to you in your project. So we have our three materials right here, and we also have some other default ones that come with Unity as well. So yeah, that is a quick look at materials inside of Unity. There is definitely a lot more to them, as there are entire jobs out there in the games industry relating to materials. So feel free to explore. You can even import some textures of your own and apply them. There's lots of different ways to discover and learn about materials. So thank you for watching. Hey everyone, in this lesson we are going to be looking at prefabs inside of Unity. So let's hop over to Unity right now and get started in learning what a prefab is and how we can use them. Pretty much, prefabs are game objects that we can save to our project files and spawn them in later or create many copies of them. Okay, they're basically templates that we can use in our games. So first of all, what I'm going to do is I'm going to go into the hierarchy here. I'm going to create ourselves a brand new, we'll make a cube here, okay? And I'm going to call this one, we'll just call this one test prefab, okay? Now with this cube, I'm also going to go to our project browser and create a new material. I'll just call this one my mat, drag that on like so, and I'm going to change the smoothness down and we'll just make it red, okay? Like so. So we have this red cube right here. Now what we can do is we can then click and drag on this test prefab and bring that down to our project window. And if we let go, a couple things are going to happen. First of all, you'll see that a new file has been added to our project browser right here called test prefab. And you'll also notice that in the hierarchy, our object is now blue, okay? It has a blue icon and a blue name. This means that it is a prefab. And down here in the project browser, we have the prefab file itself. So how does this work? Well, pretty much what we have done is we have created a template for a game object, and this blue object in our scene right now is an instance of that prefab. So let's just say we have a game and we have an enemy, right? We create an enemy game object, we set it up so that it can start chasing around our player, it has effects and everything on it. Now what happens if we want to start spawning in a bunch of different enemies around our level? Well, we could of course get the game object, copy and paste it around, but what happens if all of a sudden we want to change the enemy's move speed, for example? Well, we'd have to go through each of those game objects, modifying their move speed, and if we have a couple hundred of them, that's going to take forever. So instead what we can do is we can turn that enemy object into a prefab, and if we want to make a change to all of the enemies in our game, we only need to change the prefab, and all those changes will then get applied to every instance. So I'll show you what I mean. Down here in our project browser, I'm going to select the test prefab and drag that into our scene window. Okay, and as you can see, it has created a new game object, which is our test prefab. I'm going to drag in another one here. And there we go. So we have 3 of these cubes now. And you'll see in our hierarchy, we have test prefab 1, 2, and test prefab. And they're all blue, meaning that they are prefab instances. So let's say that we want to change the size of this cube. Okay, let's say we don't want this cube to be this size anymore. We might want it to be a bit bigger. Well, we could go through, select this prefab, select this object right here, change the scale to 1.5 a bit, select this one, scale that up, select this one, scale it up. But if we have, hundreds of objects, this might be a tree or a rock in our level where we might have, thousands of them around the place. In that case, what we can do is we can just go over to the prefab file and modify the values here. Okay, so pretty much any change we make to this prefab, those changes will be applied to every instance of that prefab. So if I go in here and change the scale to be, let's just say 1.5 on the X, 1.5 on the Y, and 1.5 on the Z, you'll see that those changes get instantly applied to these 3 cubes, okay? Because these cubes, remember, these are an instance of the prefab file right here. So they are basically looking to this prefab in order to know what they are. And any change we make to that prefab, those changes will also be applied to the instances. So again, this is just a great way of structuring your game. Whenever you start making a game and you have an object that you want basically more than one of, it's recommended that you make it a prefab, because later on, let's just say you have a door in your game, for example, and you have a bunch of doors around the place, and you're playing the game and then you decide, you know what, I want the door to open up a bit faster when the player runs through it. Well, instead of going through each and every single object that is a door and changing that value, you can instead just change one single value in the prefab, and those get applied to every instance of that door. Okay, so we can change this back to 1, like so, and of course those changes do get applied. Same thing for materials, okay? If we change the material right here to, let's just say, default-material, those materials get applied to the instances as well, okay? So any change that you make here inside of the inspector when selecting the prefab, those changes will be applied to the game object. And as well, if this game object or if the prefab has child objects, those also get assigned and applied as well. Now, what if we actually want to go ahead and edit the prefab? What if we want to maybe add more objects to it that we can't really do in the inspector here? Well, something that's pretty cool is we can just double click on our prefab and it will open up this sort of editor right here. And this is basically where we can add more objects to our prefab, change them around, etc. So in the hierarchy here, you'll see we have test prefab. I can right click on that, go 3D object, let's just say a sphere. We can then move the sphere over like so. Maybe we want this to look a bit like that. Okay, so we have a cube with a sphere. Now, if I click on the little back arrow here in the hierarchy, that'll take us back, and those changes that we made in that editor will be applied to our prefab. Okay, and as you can see, each of our instances now have that extra sphere added to them. Okay, so hopefully you can see how great prefabs are, and hopefully you'll be using them throughout your entire project, okay? And they definitely do help when making your games. So, test out the prefabs, make your own, experiment with them, and thank you for watching. Hey everyone, in this lesson, we are going to have an introductory look at lighting inside of Unity. So as you can see here, I've gone ahead and just created a little environment where I've got a 3D plane with some cubes on top, and I've also applied a material to these objects as well. Now, by default, in your Unity 3D scene, you should have a directional light game object. Now, this directional light basically acts as the sun, okay? It has parallel rays of light going in a specified direction, and you can even see on these cubes here, they are casting a shadow based on the direction of the directional light. Now, if we go and press E to go to the rotational tool, we can click and drag on this directional light in order to change the direction that this light is shining, okay? And we can even rotate it up, and you can see our scene goes dark because it's basically simulating nighttime. And we can rotate that around however we like. So there you go. Now, the directional light doesn't matter which position it's in. It only really matters the direction it's facing, okay? Now, if we select the directional light and look in the inspector, you'll see there are a number of different properties in the light component. For example, we have the color, which we can select and modify on the color wheel right here. We can have a green sun, for example. We can have a blue one. We can have a pink one. You can really change it to whatever color you wish. We also have the intensity, which defines how intense our light is. As you can see, I can bring that number up and it gets very bright. We also have shadow type, so we can change our shadows from being soft shadows to hard shadows, which may run a bit better on certain devices, and no shadows if you want to have no shadows available, which could help with performance. I'm going to swap that back to soft shadows. And then there are some other options as well, but lighting can be a very advanced topic if you go deep into it, so we're not going to look too much into that, okay? But as well as directional lights, Unity also offers a range of other types. So if I right click here in the hierarchy, I can go down to light, and you'll see here we have some others, okay? We can select point light, and this basically is a light source that emits in all directions around it. So something like a candle, for example, would have a point light like this. You can move that around and you can see the light changing as it goes. Let's change the color. Actually, let's make it a candle. So let's change the color to an orange. We might want to then up the intensity a bit. And with the point light, we also have a range property. And if we zoom out a bit, you'll see that there is this circle around our point light. And that basically defines the range of the light. Now, if we go to the edge where we have these little cubes, we can click and drag on those to increase or decrease the range of our light, or we can change the range property here in the inspector. Okay, so that is the point light. Let's move that over there. And the next light that we're going to be looking at is the spotlight. So we can right click in the hierarchy, go light, spotlight, and this is something that you would use, for example, if you have a torch or something that you want to cast in a certain cone. So you can see the spotlight has a cone that emits from its position, and the rotation determines which direction it is facing. So with the spotlight, we can rotate it. We can go over and click and drag on these little cubes at the end of the cone to increase the angle. We can even increase the range of it as well here, or we can do that over in the inspector respectively. We can change the color, so we might want to make this a green light, change up the intensity a bit, and yeah, basically, there are lots of ways to set up lighting here inside of Unity. These are probably the most common ones. A directional light, if you're having an outdoor setting, you'll most likely have a directional light. If you're indoors, then you might have point lights lighting up your environment, as they might be in light bulbs, or they might be candles or flames. And if maybe you have a street lamp, or you have some cars, or your player is holding a torch, then you might use something like a spotlight. So yeah. That is just a basic overview of lighting inside of Unity. One thing to be wary of though is a lot of lights can impact your performance, and generally lighting is one of the most performance heavy things that you can have in your game. So do keep an eye out for that, but generally it should be pretty good if you go light on the lights. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at physics inside of Unity. So let's hop over to the engine and begin to have a look. So in Unity and many other game engines, they have physics capabilities, meaning that the things and elements and game objects in your game can interact with each other with physics. So if you would have a hill, you'd be able to spawn some spheres and have them roll down, okay? So things like gravity, friction, velocity, and various external forces can be applied to your objects. So how do we get this working in Unity? Well, to start, I'm going to go ahead and create a new 3D plane, which is basically a flat ground. So I'm going to bring this to 0, 0, 0 here. So we have a flat ground. I'm also going to go ahead and create a material just to make this look a bit different. Let's call it ground, drag that on. Set the albedo to a darker color, like so, bring the smoothness down. And now I'm going to right click, I'm going to create a new 3D sphere, and I'm going to move it to the center here. Now, when we press play, we're going to switch over to our game camera, so let's actually orientate this in a position that we want. So I'm going to move it up about here. There we go. So we have our sphere. Now, if I go ahead and click on the play button, what you'll see happen is not much, okay? It just sits there because it is a game object. It doesn't know what to do. It's just a sphere sitting there. So what we can do is attach a component that gives this sphere physical capabilities. And to do that, we can go down to add component once we have the sphere selected. And we are going to add in a component called a rigid body. So select that. Let's actually close up the mesh renderer here and the mesh filter since we won't be needing those. Now, the rigid body component basically applies physics to the game object, okay? You can see here we have properties for mass, drag, angular drag, whether or not we use gravity. So if we go ahead and press play, what we should see is the ball then falls to the ground. As you can see, it's sitting on the ground. So the way this works is with a sphere collider, okay? It's important that if you do have a rigid body component attached, that you also have a collider component as well, because if your object doesn't have a collider, then there's no real point of it being a rigid body, right? Because it's not going to be ever able to hit anything or roll or have friction. So the sphere collider is basically what defines the physical boundary of the sphere. If we go to the scene view here and go in a bit, you'll see we have this green wireframe around, and that is the sphere collider. We can increase and decrease the radius of that if we wish. So if the 3D model is a bit not exactly to fit, we can change the sphere collider to match that. And the rigid body applies physics. So let's just say we want our sphere to roll down something. Well, what we can do is we can create a brand new cube here. Okay, I'm just going to make a nice simple little ramp. So I'm going to bring this underneath our sphere. I'm going to scale it a bit like so, and then rotate it like that. Okay, so we have this nice little ramp. So now if I press play, what you should see is the sphere hits the ramp and it rolls down the hill and then off the edge. Okay, so that works. Now, something else we can do on our sphere is change its settings, okay? Things like drag. Now, drag basically determines the wind resistance on this object. At a drag at 0, that basically means we're in space, and if you apply a force to an object, it is going to maintain that velocity until something else changes it, okay? Because drag isn't going to slow it down. Whereas down here on Earth, if we were to apply force to something like throw a ball, that of course would be affected by gravity, but the speed would also be affected by wind resistance, okay? The wind hitting that object and slowing it down. So for the drag, we can set this to, let's just say 1, and what we should see is that this ball is all of a sudden going to roll down here, and just before it gets over the edge, it stops, okay? Because that momentum has been slowed down by the drag. So that is one way we can apply physics to an object. Now, there's also a bunch of other stuff here, such as interpolate, collision detection, but these are for more advanced things, such as maybe player controllers, which we're not going to be looking at. There's also a constraints tab here, and this allows us to freeze the object along its positional axes as well as rotational axes. So let's just say you want to have a physics object, but you don't want it to be a rotate, okay? You might be making a player that you want to jump around, but you don't want the player all of a sudden to just fall over on its side when it hits a little bump, okay? In that case, you'd probably want to freeze the rotation along these axes here. But we don't want to do that since a ball, it needs to move in 3D space and it needs to roll. Now, the physics is also pretty realistic, so we could go ahead, duplicate this ball a bunch of times like so, and just see what happens, okay? So we have a bunch of those there, press play, and we should see them all interacting with each other like so. And yeah, you know, it can be pretty fun to mess around with Unity's physics, adding in your own sort of things, maybe eventually have a player running around, hitting boxes, as it's always great to have physical interactions like this within your games. So yeah, that is just a quick look at the rigid body component, which applies physics to our game objects. You can also do the same for cubes and for any other object that has a collider attached, okay? It's important that your rigid bodies have colliders because otherwise they're not really going to be interacting with the world at all. So yeah, thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to have an introductory look into scripting. Now, scripting is a very important part of the Unity game engine, and it's basically what allows us to create our games. So, what is scripting? Well, basically it's how we create the gameplay behaviors and logic for our games. Now, scripting, it can also be known as coding or programming. Generally, those words can be interchangeable, although they do have their own specific meanings, but generally, when somebody says they are coding in Unity, that normally means they are scripting or they are programming. Okay, this is basically coding. We are writing code to give instructions to the game engine in order for it to do certain things. Okay, now a script is a file that we can create which contains code. Okay, think of like creating a new Word document or a new Notepad document. It is a file which contains the text of the code that we have written. So if we, for example, want to create a player controller which moves our player around, we would create our player controller script, and in there we would code all of the behavior for that player. Now, it's also important to note that a script is essentially a custom component. Okay, we are basically creating our own components inside of Unity whenever we create a script. So that means we have the ability to attach our scripts to game objects. Okay, so in the case of that player controller, we would essentially attach it or add it to our player game object, and then that script can basically interact with that game object, moving it around, and also maybe even communicating with other components that the player might have. Now, let's hop over into Unity and look at how we can create a script and how we can add it to a game object. So here I am inside of Unity. Now, the first thing we want to do is to go down to our project window here. And what I'm going to do is I'm going to create a script. So what we need to do is right click in our project window, go up to create, and you'll see here at the top it says C# script. So I'm going to click on that and you'll see it creates a new file. We can then give it a name here when it is highlighted. And I'm just going to call this one my first script, or you can really call it whatever you wish. And then hit enter and it will create it. Now, what is C#? Okay, and you'll see we also have this hashtag or pound icon on the file. And C# is essentially the programming language that Unity uses to write its scripts. Just like you have English, French, or German, there are many different types of programming languages, okay, or coding languages. And Unity specifically uses the C# programming language for us to write our scripts, okay? And that is what we are going to be looking at for the rest of the course. We're looking at how we can start writing code and get a better understanding of the C# language and how we can interact with Unity in order to make our games. So, we have our script file right here. Now, what can we do with it? Well, we could open it up and start writing code, but before we do that, let's go and look at how we can add it as a component. Now, basically, once we create our script, it is essentially all done for us, okay? It has automatically been added to Unity's list of components. So what we can do is if we go over to our hierarchy, I'll right click and create a new 3D cube here, okay? And all we need to do is select the cube, and just like adding any other component, it works the exact same way. So we can go to the inspector, go down to the add component button, and what we can do then is we can of course go through our list of all the components, or we can go to the search bar here and type in my first script, and here you'll see it pop up. We can click on it and my first script will be added as a component, okay? So we can open and close it, we can enable and disable it, we can even right click and remove it, okay? It's basically a component that we have created. So we can also click and drag on the script file and bring that into the inspector to attach it like so as well, okay? So generally, if you don't want to go through the add component button, you can just click and drag your script onto a game object to add it quickly. So we have our component created. Now, how do we actually start writing code for it? How do we start writing logic so it can do something? Because right now, if we were to press play at the top here, we'd press play and nothing would happen. And that is because the script is basically empty. It contains no code, no logic. So how do we start writing that? Well, we just need to go down to our script file right here and double click it. And what that should do is open up the Visual Studio code editor, okay? Now, there may be an initial setup that you need to do where it may ask you to log in, and you can of course then log in with a Microsoft account or any other account that it provides. And once that script opens up, you should have Visual Studio open like so. Okay, yours may look a bit different just because I've changed the layout a bit, but generally you should have this program open. It may prompt you to log in. If so, just go through that process, and once it opens up, we should see our code right here. Now, Visual Studio is essentially a development environment, okay? This is a program which specializes in writing down code. Now, you could, for example, have Notepad or Microsoft Word as your code editor, yet that would be not a good idea because a program like this specializes in making writing code as easy and as comfortable as possible, okay? Things like autocorrect, automatic formatting, and coloring the bits of code to make it easier to read are just a few of the affordances that a program like this provides. So, initially, we'll see this bunch of code right here, okay? Things like using system.collections, public class, void update. Initially, you're going to look at this and have no idea what any of it is, and that's fine, okay? When starting out, code can be quite daunting, but what we're going to do in this course from here is go step by step, looking at the very basics, the foundations of programming and understanding the logic behind it so that we can then start creating our games, okay? And for most of this course, we are going to ignore a lot of this stuff here, as that's really just a lot of the boilerplate stuff that we need in order to structure our script here. For now, we want our script or our component to actually do something. So what I'm going to do is I'm going to go over here to where it says void start. Okay, you see it says void start, and then it has these two little brackets, and then these squiggly brackets right here. Now, we're going to be going over this in a later lesson, but this is essentially a function, and it's basically a block of code which can run whenever we want. And you'll see after void start, it has these two squiggly brackets, and basically in between them, we can write some code. Now, the start function basically gets called once at the start of the game. So when this object is initialized, the start function will be called. So what I'm going to do is inside of start here, between the opening and closing squiggly bracket, what I'm going to do is I'm going to select. You should see it's automatically indented a bit as well. And I'm going to write debug.log. Now you should see when you're typing it, it pops up with this autocorrect window. So you can just hit enter and it will autocomplete whatever you're writing. And then in two brackets here, I'm going to put two quotation marks and just write hello. Okay. And then at the end, I'm going to put a semicolon to end that off. Now, looking at this, it's probably confusing. What's debug? What's log? Why do we have to put a semicolon here? We'll be going over this a bit later on, but for now, let's just get something working, all right? So debug.log. What we can do is we can go then Control S, or you can click on the little save button up here to save the script. We can then minimize this window and return to Unity. Okay, now nothing looks different. Our script is still here, but if you select the script, you'll see in the inspector we have a little preview of it, and we can see that that debug.log line is there. Now, if I press play, what you'll see is down here in the console, we have a new message, and that's because debug.log is essentially a line of code which allows us to print messages to our console. Okay, so this basically allows us to see if the code works, and since it says hello down here in the console, we know that our script is working and it is running. So that is an introductory look at scripting inside of Unity, and in the next lesson and for the rest of the course, we are going to be going over the different fundamentals of programming and interacting with the Unity engine. So thanks for watching, and I'll see you all then. Hey everyone, and welcome. In this lesson, we are going to begin creating our balloon popper game. So to begin, we need to go ahead and create ourselves a brand new Unity project. Here inside the Unity Hub, we can go over to New, and I'm going to just go ahead and I'm going to call this one, let's just say we're going to have Unity Micro Projects, all right? Make sure it is a 3D template. You can choose a location where you want to save your project files to, and then we can click Create to, of course, create the project and open up the Unity editor. Okay, so here we are inside of Unity. Now the first thing we're going to do is I'm going to go ahead and create a brand new folder here inside of our project browser, and this folder is going to be called Balloon Popper, okay, because we are going to be creating various different projects in this course. The first one, of course, being the balloon popper. So we're going to make an individual folder for each just to organize them a bit easier. And then inside of the balloon popper folder, we are going to create a new scene for the balloon popper game. So we can right click, create scene, and this one is going to be called balloon popper, like so. We can then double click on it to open it up, and you should see here in the hierarchy, we have the little scene icon and it says balloon popper. Okay, so we're inside of the scene now. Now let's set up the main sort of mechanic of our game, which is going to be clicking on the balloons in order to pop them. So how do we create our balloon game object? Well, for this, what we're going to do is we are going to just go into our hierarchy here. We're going to right click and go down to 3D object sphere. Okay, we're just going to keep it nice and simple. We're just going to have a sphere as our balloon. And of course, let's give this a name of balloon. There we go. Now over here in the scene view, we can of course move our camera around and get closer to our ball, or we can press F to focus in on it automatically like so. Make sure that over here in the inspector, your position is at 0 on the X, 0 on the Y, and 0 on the Z. And if you click over into the game view tab, you should see that the balloon is nice and centered on the screen, okay? So now what we can do is let's give it a material, because right now we just have this plain white balloon and, you know, it doesn't really pop. You know, balloons generally have colors. So down here inside of the project browser, I'm going to right click, create, go material, and this one is going to be called, we'll call this one red balloon. Okay, we'll go over to the scene view here. Let's drag this red balloon material onto our sphere, like so. Now nothing's changed, and the reason why is because if we click on our material, over in the inspector, we can modify the properties, okay? What sort of material is this going to be? So over here, what we want to do is change the color. Now to do that, we need to go over to the albedo, which is basically the base color of the material. And you'll see to the right of it, we have this little color selection box. Okay, we're going to click on that. And then this window will appear where we can select a color, okay? Just your standard color picker that you've probably seen in other pieces of software before. So we can go over here, we can get a nice reddish color like that. There we go. Look in the game view, and there we go. We now have our red balloon. And we can also modify other properties, such as the smoothness, which is at 0.5 right now. And you can see that the smoother I make it, the more sort of reflective the balloon is, okay? Or we can bring it all the way down to make it a nice sort of matte colored red. Or all the way to 1 to make it a reflective sort of surface. Now, balloons aren't too reflective, although they are kind of, so I'm just going to set smoothness to be 0.5, okay? Just the default, and there we go. Now, as a bit of a challenge, I want you to go ahead and duplicate this balloon, so let's go ahead and do that right now real quick. Okay, so I'll just move this over, Control D or Command D on a Mac, drag it over here, do that again, and look in the game view, make sure that you can see them on the, on the same row here. You might need to move them around a bit in order to get that perspective right. And what I want you to do is I want you to go ahead and create a material for a blue balloon and a green balloon material, okay? So create those two new materials and apply them to the other balloons right here. So I'll be right back to see how you're done. Okay, so I hope you had a go at that. Pretty much what we need to do is go back down to our project browser, and I'm going to right click, go create, material, and I'm going to call this one blue balloon. Okay, scene view, drag that onto the middle one here, and I'm going to set the albedo for this one to be a bluish color, something like this. There we go. And then finally for the last one, we need to create a material, call this one green balloon, assign that to the other balloon at the end here, set that color to be green. And there we go. So now we have our 3 different balloons of 3 different colors. Now in the next lesson, what we're going to do is set up our balloon script so we can finally start clicking on them to make them bigger, and then once they reach a certain size, they will pop. And then alongside that, we're also going to have another script which manages our score, okay? So each time we pop a balloon, a certain number will be added to our score, and then eventually we'll have some text on screen displaying that score. So I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to continue on with our balloon popper game by adding in a balloon script which is going to be able to detect clicks and increase the size of the balloon. Once it reaches a certain size, it will then pop and add score, which we can then have displayed on screen. So to do this, let's start off by going down to our project browser here. I'm going to right click, go create C# script. Let's call this one balloon. And what I'm going to do is, over in our scene view, let's select all 3 of our balloons here. So hold down shift and click on each of those to select all of them. You should see here in the hierarchy. And I'm going to drag on the balloon script right here to the inspector to add it as a component. So each balloon now has the balloon script component. We can then go ahead and double click on this balloon script here to open it up inside of Visual Studio. Okay, so here we are inside of our balloon script. Now let's have a look at the different things that are already here by default. First of all, at the top of the screen, you'll see we have these using things, great, okay? Using system.collections, using Unity Engine. Basically, these are all of the libraries that we are accessing, and a C# library is basically a bunch of code that we can implement in order to do certain things. For example, using Unity Engine allows us to access a lot of the Unity related functions. And then over here we have public class balloon. Public class is basically defining this as a class balloon, which is the class name. And you'll see here we then have a colon mono behavior. And this here is basically which class we are inheriting from. So which class are we inheriting variables and functions from? And that is mono behavior. And mono behavior is a class which basically allows us to connect this script as a component, allows us to attach it to a game object. And then down here inside of the class, we have 2 functions already set up for us. The start function right here gets called at the start of the game before the first frame, and update gets called every frame. Now for this balloon script, we don't want to do any of these, okay? So let's select both the start and update functions and just delete them. And now what we want to do is instead we want to create a function called void on mouse down. Okay, and on mouse down is a function that is built into Unity. Okay, it's built into mono behavior right here. And you want to make sure that it is spelled correctly, okay? On mouse down, capital letter for each word. And you'll see here that it is being highlighted in blue. And on mouse down, if you hover over, you'll see here that it says on mouse down is called when the user has pressed the mouse button while over the GUI element or collider. So when our mouse is over this object's collider and we left click, this function gets called. Okay, so what we want to do on here is basically increase the size of the balloon and then pop it when it's ready to pop. So how do we know how much score we want to give, how big we want to make the balloon, and how many pops we need to click? Well, for that, we are going to be creating some variables. Okay, and variables are basically pieces of data that we can assign to a class, and it can hold information. So here I'm going to go public int for score to give, and we'll give it a default value of 1. So basically what we're doing here is we are defining the scope of the variable. Public basically means it can be accessed inside and out of this class, and it's also being displayed inside of the inspector, so we can modify it there on the component. Int is defining the data type, which is of type integer, so a whole number. We then give it a name, and then optionally we can assign a default value, which we have done here with 1. The next variable is going to be a public int for clicks to pop, and we'll set that to be 5 by default. Clicks to pop is basically how many times we need to click on the balloon to pop it. Okay, score to give is how much score we are going to add, and clicks to pop is how many times we need to click on the balloon. And then what we need to do is we need to create a public float scale increase per click. And I'll set this by default to be 0.1. Now, float is a floating point number, so that basically means a number with a decimal. We're calling this one scale increase per click. This is how much we're going to increase the balloon scale by each time we click on it, so it gets bigger and bigger. And the default value is 0.1. Okay, so we're increasing it by 0.1 each time we click on the balloon, and this F at the end just defines this number as a float. Okay, so whenever you want to write down a float, you do need to put an F behind it. Now, what we can do is go down here to on mouse down, and first of all, we click on the balloon. Let's subtract 1 from clicks to pop. Okay, so to do that, we can go clicks to pop minus equals 1. Okay, so we are subtracting 1 from clicks to pop. Then what we need to do is increase the scale of the balloon. Now, to increase the scale of the balloon, we need to access this object's scale property. Okay, so if I save this script real quick and return to Unity, let's go over here and click on a balloon. You'll notice that the component has all the properties here, so we can modify them if we wish. But the property we want to modify is scale right here, okay? So we have X, Y, Z on the scale, and you can see how when I increase the scale along the X, the Y, and the Z, it basically makes the object larger. So to do that, we need to access the transform component. So for this, we can go transform.local scale, which is the property that modifies the scale. And then we want to go plus equals vector3.1 multiplied by scale increase per click. Now, a vector3 is basically a piece of data that contains an X, Y, and Z value. And vector3.1 is a sort of preset vector which has 1 for the X, 1 for the Y, and 1 for the Z. So if we multiply that by scale increase per click, we're basically increasing our X, Y, and Z scale by 0.1. Okay, so that's what this line of code here does. We're increasing our scale by this much right here each time we click. So let's save this script, return to Unity, and test it out. So let's press play, and if we click on a balloon, you should see, there we go. I'm clicking on it, and we can make it as pretty much as big as we want. If we stop playing and we click on the balloon, let's change the scale increase per click from 0.1 to 0.5. Let's make it a bit bigger. We'll press play. And now if I click on it, you'll see that it is increasing at a much larger scale here. And if we look over at the top right corner, you'll see the scale variable here is at 5 right now. I click on it, 5.5, 6, 6.5, and it keeps on getting bigger. But there is a problem, and that is that we can keep on clicking on this balloon forever, and it's not popping. So first of all, what I'm going to do is I'm going to change the scale increase per click back to 0.1. And in the next lesson, we are going to be working on actually popping this balloon and adding our score. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to continue on with our balloon popper minigame. So what we're going to do now is start working on being able to pop our balloon and add score to it. So to do that, what we're going to do is we are going to first of all go down to our project browser, and we are going to create a brand new script. And this one is going to be called Score Manager. Okay, just like so. So with our Score Manager, we need to attach it to a game object in our game. So to do that, I'm going to right click in our hierarchy, and I'm going to create empty. And what create empty does is basically creates a game object with no components. And I'm going to call this one Score Manager. Now, if you have scripts that aren't really modifying the position or modifying anything attached to that game object, then generally it's good to attach it to an empty game object to act as sort of a container for management scripts. So there we go. Then what we can do is open up our Score Manager inside of Visual Studio. And this Score Manager script, we can delete these start and update functions since we won't be needing those just yet. What we're going to do is we are going to create a variable. And this variable is going to be a public int for our score. Now, this is going to be the variable which keeps track of our total score. So whenever we pop a balloon, this is going to increase. So how do we increase the score? Well, for that, what we're going to do is we are going to be calling a function on the Score Manager. So if we go to a new line, what we're going to do is we're going to create a function called increase score. And it's going to have a parameter. So it's going to have an input into the function where we can send data into it. And it's going to be of type integer, and it's going to be called amount. So all we want to do inside of this function is just go score plus equals amount. So when this function right here is called, we're going to be sending over an amount, and that amount is going to be added to our score variable right here. Now, where and how do we call this increase score function? Well, in order to call it outside of the script from the balloon script right here, we need to make this variable public. Or we need to make this function public, I mean. And to do that, it's the exact same way as making a public variable. We just need to add the keyword public behind it. Now, if we weren't doing that, and if we just had void, then that means it is a private function. And a private function can only be called within the script or within the class that it was created. So we won't even know that this function exists over here in the balloon script unless we make it public. Okay? So now what we can do is go over to our balloon script, and we need a way of calling that function. So how do we do that? Well, in order to do that, we first of all need to have a reference to the score manager component. And to do that, let's create a new variable here. It's going to be public score manager, and we'll call it score manager. Okay, so the type of variable is going to be this score manager component, okay, or this score manager script right here. So if we save this script, go back into Unity, what you'll see is if we select on one of our balloons, you'll see over here that on our balloon script, we have a score manager property, and what we can then do is drag in our score manager game object. It's going to assign that component to that property right here. Let's do the same for our other balloons. Drag in the score manager like so, because on our score manager game object, we of course have the score manager component, okay, right here. So now what we can do is inside of our balloon script, we can check to see if our clicks to pop is equal to 0. Okay, so here, I'm going to, at the bottom of this function, I'm going to go if clicks to pop equals 0. So if the clicks to pop is equal to 0, then we are going to increase the score. So to do this, we can go score manager dot increase score. You can see here we can access that function, and we're going to be sending over the amount, and the amount is going to be score to give. Okay, this variable right here. And then finally, once we pop the balloon, we want to of course destroy it. So to destroy an object inside of Unity, we can just call the word or call the function destroy. All right, sending over the game object we want to destroy, which is going to be game object. Make sure it is a lowercase g, capital O, and this word right here basically refers to this game object, okay? The game object that this script is attached to. So we can save that, we can return to Unity, and what we're going to do is we're going to select our score manager and keep an eye on this score property right here, okay? Let's see if it goes up. So I'm going to press play, and let's click on the red balloon. You can see once it popped, it got destroyed, and score is now equal to 1. Let's do the blue one. There we go, score is now equal to 2, and for the green, score is now equal to 3. Okay, so you can see it is increasing right here, which is pretty good. Now on our balloons, we can of course change the score to give property. So on the blue balloon, let's set this maybe to, we'll go 2, and on the green balloon, we'll set it to be 3. So the red balloon gives us 1 score, blue gives us 2, and green gives us 3. So if we select our score manager again, and if we pop the red balloon, there we go, score has been increased by 1. Click on the blue balloon, there we go, score has been increased by 2, and finally, once we pop this green balloon, our score should be equal to 6, okay? 3 plus 3 is 6. And there we go, our score is increased by 3 again. So yeah, that is how we can pop our balloons and also communicate with other scripts inside of Unity, okay? Because once it comes down to actually creating games and creating all these interacting systems, you will be having different components, different scripts communicating with each other, okay? And this is just an example on how to do that. We have our balloon script, which is communicating to our score manager when it gets popped, and it's calling a function on the score manager when it gets popped. Okay, so in the next lesson, what we're going to do is we are going to be looking at Unity's UI system, and we are going to be setting up some text here to be displayed on top of the screen, okay? And that is going to be our score text. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at Unity's UI system in order to create some text on top of our screen. So what we're going to do first of all is let's hop over into our scene view right here. Okay, and we need to create something known as a canvas. Now, a canvas is basically going to be the container which holds all of our UI elements. And the canvas can change size based on your screen's resolution and aspect ratio, thus having the elements inside of it react based on that. So what we're going to do is in our hierarchy, let's right click and we want to go down to UI, and then you see here there's a lot of different UI components we can choose from, but we're going to go down to canvas, okay? And as you can see, it's created two new game objects. It's created a canvas, which if we look over here, you can see it is very, very large. And it's also created an event system. Now, an event system is basically a component which allows us to interact with UI objects. So if we click on a button, if we drag a slider, this is basically going to be in charge of that. So it's good to have an event system here, and luckily it gets created automatically for us, so we don't need to touch any of this. Now let's select our canvas right here, and you'll see over here on the right hand side, we have a number of different components. Now, first of all, you may notice that our transform component is missing, or more so, our transform component has been changed to something known as a rect transform right here. Now, a rect transform is basically the replacement for a transform component that each UI object has, okay? So our buttons, our text, any sort of UI element you want to add to a canvas will have a rect transform component. Now, this is different to a normal transform component. You'll see here that it does have position, X, Y, Z, it has scale, it has rotation, but it also has width, height, pivot, and anchors, okay? The width and the height, that's pretty self-explanatory, basically how wide and how high in terms of pixels is this UI element. Anchors and pivot, we'll get to that in just a second. So we have our canvas right here. Now to get in a bit of a better position for working with it, what I'm going to do is go over to the top left corner of the scene view, and you'll see here there is a button that says 2D. I'm going to click on that 2D button right now, and you'll see it turns us into this 2D mode. So we can zoom out, we can hold right mouse to pan around, but I'm going to click on our canvas and press F. And as you can see, we have now focused on our canvas right here. So we can zoom into it, but there's nothing on our canvas just yet, so nothing really to modify here. So let's add in some text. So what I'm going to do is I'm going to right click on the canvas game object in the hierarchy, and I'm going to go down to UI text-text mesh pro. Okay, you see there is one that says text, but we don't want to do that. We want to go down to text-text mesh pro and click on that. Now this window is going to pop up. You just want to click on the import TMP essentials. Now, Text Mesh Pro is basically a package that comes with Unity. It used to be a third-party asset that you could download from the asset store, but in recent years, Unity has sort of integrated it within the engine itself, so it's now a part of Unity. And Text Mesh Pro is basically a really good way of displaying text in games. Rather than having a text being made up of a bunch of pixels, it's instead made up of a mesh, which allows us to get really fine and crisp text, okay? But we don't need to worry about all that. We can then exit out of the TMP importer window right here, and you'll see in the middle of the screen, we have our text element, okay? You see it has the rect transform component, it has a canvas renderer component, which is basically there to render on the canvas, and it has a text mesh pro -text component, which has all the different properties that we can modify. So if we zoom into this text here, you'll see a number of things. First of all, we don't have the XYZ move gizmo ready to move it around. Rather, we have this new tool, which is the rect tool up here at the top left. Okay, of course, we can switch to all the old ones. We have the move tool that we know here, but the rect tool allows us to modify the width and the height of this object. So we can just click and drag on this object here to move it around our canvas. And you can see here that if we bring it to one of the edges, it'll snap into place. So finally adjusting things and snapping together is really good with Unity's UI system. You can even see it snaps directly into the middle as well, along the horizontal and vertical axes too. And these blue circles on the four corners allow us to click and drag to resize this element, okay? So if we want a larger text area, we can of course make it bigger. We can also click and drag on the sides here. You don't want to click and drag on these little white cubes though, as they do increase and decrease sort of the margins. So we don't really want to modify those. Rather, we just want to click and drag on the vertical lines and horizontal lines. Okay, so I'm going to make a text box about this big, I'd say. We can then drag this to the top of the screen since that's where we want our text to be displayed. Okay, there we go. And if we look into our game view now, you'll see here that the text is being displayed on screen. Okay, so let's get to actually creating our text. I'm going to first of all rename this game object to be score text. Okay, and then let's give it some placeholder text to just display. So down here where it has new text, we can rename this, or we can change what is being displayed. So what's going to be displayed is just going to be score, we'll put a colon, and then we'll just have an example of, let's just say 500. Okay, there we go in the game view. Then we can modify the properties down here. There are a large number of different text properties inside of Unity. We can make it bold, we can make it italic, underline, all these different things here. We can increase and decrease the font size. So let's maybe increase the font size to about 40, or make it bold. We can change the vertex color, which is just the color of the text. Let's make that a sort of darkish color like so. If you look in the game view, that's what it looks like. Okay, we can also set the alignment. So down here, we can align it to the left by default, the middle, the right. I'm going to align it to the middle, and then we can also do the same vertically. Okay, top, middle, bottom. I'm going to align it to the middle. Okay, so now the text is centered within this, within the bounds of its object. Okay, there we go. We don't really need to worry about any of the other things down here. These are more material related aspects. But what we can then do is look at the anchoring. Now the anchoring is what allows us to have dynamic UI that changes based on the resolution of the screen. So if we go into the game view right now and we sort of undock the game window, okay, just drag it out, you'll notice that if I resize the game view, you'll see that the score text is sort of staying in place, okay? It's not moving with the screen. But what we want to do is sort of attach it to the top of the screen. So when we make the screen really small like this, the score text is just underneath the top of the screen. And when we make it really tall, we also want the score text to be there as well. We don't want the score text to sort of sit in place like it is right now. Okay, and the reason why is if we dock this back, the anchoring is set to center. So as you can see right here, we've got this little thing inside the rect transform. If we click on it, you'll see the anchoring is set to middle center. This basically means that the object is going to remain at this specific distance in terms of pixels from the center of the screen. But what we want to do is set the anchoring to be at the top center. So to do that, we can select the anchor gizmo here and just set it to be top center. And you can see that the 4 little anchor arrows have also moved to the top center of the screen here. So now we can undock the game window, and if we resize it, you can see that the score is remaining at the top of the screen. If we make it very tall, if we make it very squat like this, you can see that it is still remaining on screen at all times. That is because it's basically attached to the top of the screen, and it is always going to remain a specific pixel offset from the top. Now, in the next lesson, we're going to look at actually implementing this text into our score manager and being able to modify it inside of the script. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be connecting our score text right here to our score manager script. So let's open up the score manager right here inside of Visual Studio. And first things first, we need to create a variable that references the text component, okay? If we want to actually access it and modify what it is being displaying, we need to access the text component. Now to do this, we first of all need to go to the top of the screen here, and we need to be adding in using TM Pro like so. Okay, TM Pro is basically Text Mesh Pro's library, which allows us to access the different classes that we need. Okay, so down here then, inside of the score manager, let's create a new variable. This is going to be called public, and it's going to be of type text mesh pro UGUI. Okay, it's pretty long data type here, or pretty long class. And I'm going to call this one score text. Okay, just like so. Now, as well as this, we need to also create a function which updates the score text to display the current score. So to do that, we can go void update score text. And inside of this function, what we're going to do is go score text dot text. Okay, the dot text is the property which allows us to modify what gets displayed. And this is just going to be equal to, and I'm going to make a string here. So we're going to go score colon, I'm going to put a space, and then we can combine this string with a number. So we can combine it together by going plus score. Okay, and what this will do is basically have the text display score, colon, a space, and then however much score we have. Now, this update score text function does not need to be public due to the fact that we are only going to be calling it within this class here. So where are we going to be calling update score text? Well, first of all, we want to call this function whenever we update our score. Whenever we increase our score, we want to call it. So after we add the amount to our score, we want to call update score text. And then we also want to call it at the start of the game, okay? Because right now we have the placeholder 500 on our score text. We of course want to set that to 0 at the start of the game. So up here, I'm going to create the void start function, okay? Which gets called once right at the start of the game. And inside of here, we just want to call update score text, okay? Just like that. And this should be all the code necessary in order to update our score text when we increase our score as well as at the start of the game. So back inside of Unity, what we're going to do is go over to our score manager object right here. And on our score manager object, you'll see here, of course, we have the score text component. We can drag that in. There we go. Press play, and we should see that score is 0. Now, if we pop some balloons, there we go, 1, 3, and we should then see 6. And there we go. So you can see the score text is being updated, so it's working just fine. Now from here, pretty much what you can do is go ahead and duplicate a bunch of these balloons, start placing them around the screen. Also, if you wish, you can create new materials. You can set, different types of balloons which have different amounts of clicks required to pop them, different amounts of score they give, different scale increases as you click on them. So yeah, good luck with that. And throughout this project, we pretty much looked at working with multiple scripts and being able to communicate between them. So we have our balloon script and our score manager. The score manager contained the variable for our score, and whenever our balloon popped, we were basically telling the score manager to increase the score by a certain amount. And then we also looked at Unity's UI system. We looked at quite just the basics of it, with just having a little bit of text on top of our screen. But if you right click on canvas, go UI, you can see there is definitely a large number of different components. There's input fields, drop downs, sliders, buttons, etc. So do feel free to start experimenting with those and connecting those up as well, as they can be very useful in your games. So thanks for watching. Welcome back everyone. In this lesson, we are going to be looking at setting up our input actions, okay? Setting up our input map, which is going to basically detect whenever we press a button on our keyboard or our controller or whatever sort of device you want to connect, what is that going to do? What action is it going to trigger? So to set this up, let's go over to the other folder. I'm going to right click, I'm going to go create, and right at the bottom, we have input actions, okay? I'm just going to call this one input actions right here. Doesn't really matter what you call it. And then what we can do is double click on it to open up. Now, this is going to open up the new input actions window right here. And there's a few things. First of all, over on the left-hand side, we have the action maps section right here. Now, action maps are basically like categories of controls, okay? They're basically control sets. Now, typically, you only really want to have one, so that's all we're going to create. So let's go ahead, click on the plus right here, and I'm going to call this one main. So this is our main action map that we're going to be using. In the middle is where we have our actions, okay? Now, with the new input system, it is made up by a collection of actions, okay? So an action will be something like move, jump, or attack, in our case. And each action can then have key bindings or buttons attached to it that trigger such action, okay? And those can be defined over here in the properties window. So for our first action, I'm going to double click to rename it, and this one is going to be the attack action, okay? So what button are we going to press to attack? Well, we can click on this little down arrow, and as you can see here, it's created a new child object, which is a binding. Now, a binding is a button or a controller press or whatever to basically call this action, to trigger this action. So if we go over to path, and as you can see here, there is a wide range of different controllers and input devices that we can choose from. We have gamepads, joysticks, keyboard, mouse, pen, even VR and XR controllers right here, which is very nice. All we're going to do is look for the space key, okay? The space bar is what we're going to be using to attack on keyboard. So there we go, space keyboard for attack. Now that's all good, but what about controllers, okay? Because we're using controllers as well. So how can we basically set up a key binding for controllers as well? Well, to set up multiple different devices, we can go over to where it says no control schemes, and we want to go add control scheme. Now, a control scheme is basically a way of inputting actions, okay? Are you basically inputting actions through a keyboard and mouse? Are you doing it through a controller? Are you doing it through a joystick? So let's click on add control scheme right here. And the first one is going to be our keyboard, okay? And we then want to go over to where we see list is empty. And this is where we are going to list all of the input devices that fall under this control scheme. Okay, so click on the plus, and I'm going to click on keyboard. Now, that's all we need to do. For requirements, this is going to be optional because since we are, allowing controllers, players might not want to play on a keyboard. If they have, 4 controllers, let's give them the option to have 4 controllers, and one of them doesn't have to be on the keyboard. So, requirements, optional right there. Hit save. And as you can see right now, space is a global control scheme. So basically, everybody, no matter what device, will be able to use the space bar. But we don't want that, okay? We only want keyboard players to be able to use that control scheme. So over here in properties, click on keyboard, okay? Now let's create our controller control scheme as well. Let's go keyboard, add control scheme, and this one is going to be called controller. Okay, now for the list right here, we can open that up, and let's go over to where we have gamepad. Now, you might be tempted to go down, okay, PS4 controller or Xbox controller, but we don't want to do that. We just want to go to where we have gamepad up here. Now, Unity has a sort of universal gamepad input right here, which basically falls under every controller that you can, feasibly get, okay? So it has sort of universal buttons for the left stick, the right stick, the D-pad, the triggers. But if you do want to be specific, for example, if you are using the PlayStation 4 controller's touch pad interface, then you might want to do that specifically. But since we're just, designing this for any sort of controller, we can just click on gamepad right here. Let's make that optional, hit save. Now you see suddenly that option appeared under attack. It disappeared, and that is because we are currently in the controller control scheme here. We can switch between them just like so, and on controller we need to give an input for attack. So let's go over to this plus right here, and we're going to go add binding, and this binding, if we go to the path, we can then go over to gamepad. We then want to go button west. Now if you have a controller with you right now, if you look on the right-hand side, you have your A, X, Y, B, or your X, square, circle buttons if you're on a PlayStation controller. And you have the north button, the south button, the east button, and the west button, okay? Now, the west button is going to be the one on the far left, so X on an Xbox controller. And that is what we're going to do for attacking, okay? So, as you can see, it is enabled by controller by default since we are in that control scheme right now. Let's go ahead and also set up our jump button or our jump action. So I'm going to go create a new action right here. I'm going to call this one jump. Now for that binding, we're going to make this a gamepad, and that is going to be the south button, okay? So we go here, find where we have button south right here, and that is going to be the A button on an Xbox controller. Now let's switch over to our keyboard control scheme and assign the jump button as well. Now, for the jump button on the keyboard, this is just going to be the up arrow. So we can just search here for up arrow like so, and there we go. Now, one more action we need is our movement. Now, the movement is going to be a bit different. And the reason why is because it's not going to be a single action for move left or move right. Rather, we are going to be using a 1D axis. So let's click on the plus here for a new action, and I'm going to call this one move. Now for move, we want to go down to the binding and actually delete that. So right click and delete it. And instead, we're going to create a new binding. So click on the little plus next to move here and go add 1D axis composite. Okay, we can just call this 1D axis. That doesn't really matter what this is called. But you'll see here that we have a negative and a positive binding. Well, what this means is basically move is now a 1D axis. So it can be either -1 or 1. Okay, if we want to move left, we're going to be setting this value to be -1. But if we want to move right, we want to set this value to be +1. Okay, and to do that, we can go down here. So negative, this is basically what we use to move left. So for this, we are just going to go path, and we're going to go left arrow. Okay, and for moving right, this is going to be our right arrow. Okay, so we can press left and right on the keyboard, and that is going to basically change this move action's value from -1 if we're moving left to +1 if we're moving right, and 0 if we're not pressing anything. And we can then use that value to determine our velocity for left and right. All right, so let's switch over then to our control scheme here. And for move, what we're going to do is pretty much the same thing. Okay, click on the plus, 1D axis composite. For negative, this is going to be our left stick. Okay, so we'll go path, go over here to left stick, left. Okay, so if we hold our left stick towards the left, that's going to move us in the negative. And for the positive, that is going to be left stick right. Okay, so left and right. So we have all of our actions set up right now. Let's click on where we have save asset right here to save all changes. And let's just go over it again real quick. Okay, so over here we have our action maps. These are basically the overarching categories or containers of actions. So most games will only really have one action map, so that's all you'll ever need to create and just have all of your player actions listed down here in the actions window. And an action is pretty much like a trigger or an event that gets called when a certain binding is activated, okay? So down here for our controller, if we click on the button south, which is the A button on an Xbox controller, this jump action is going to be triggered. And we can then connect this to a script through a Unity event, so we can call a specific function when the jump action is triggered. And we can then do whatever code we want from there. Now down here with the move, this is a 1D axis. So this isn't just one button that is either being pressed or not, okay? It's not a digital pressed or not. Rather, it's a more analog value that changes, okay? So we're looking at a float value for this action. And when this action gets called in the script, we'll have a function that basically can then read the float value, okay? And that float value can be -1 to 1, -1 if we're moving left, +1 if we're moving right, and 0 if we are just, standing still. And we then have our control schemes right here for our controller and for our keyboard, okay? Because of course, if you're playing on the controller, you need to have different button inputs right compared to if you're playing on the keyboard and mouse. So we've got everything set up right here. Again, save that asset as it doesn't save automatically unless you click on auto save right here. We can then exit out of this screen back into our game. And in the next lesson, we are going to be working on setting up our player and connecting these input actions. So thanks for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to be working on our player object, okay, our player prefab that we can move around, jump, and attack. So to begin, let's go to our scene view. I'm going to zoom in here, and we are going to right click in the hierarchy, and we are going to create a brand new empty game object. I'm going to call this one player, and let's just set their position to be 0, 0, 0, so they're nice and centered on our screen right here. And we need to add a few components, okay? First of all, we need a component to basically give our player physics, okay? So I'm going to go add component, and we're going to add in a rigid body 2D right here. We then want to add in a capsule collider 2D to give our player some collision so that they don't just fall through the ground. And, next up, let's actually be able to see our player. So over in the sprites folder, let's open that up. Let's open up our player sprite sheet right here and drag in the player 0 sprite as a child of player. Okay, I'm going to rename this object to be sprite, and you'll see that, they're not being rendered, and that is because our sorting layer needs to be set to player. And there we go, we can now see our player. Now, with our player sprite, when they're going to be spawned in the world, what we're going to be doing is changing their color based on how many players are in the game. Okay, so the first player will be red, for example, second player will be green, third player will be blue, and then fourth player may be pink or something, okay? That is why our player is sort of black and white, so we can easily change the color and change the tint as we wish. Alright, so let's go over to the player object right here. What we're going to do is change their tag, first of all, to player, so that they are on the player tag, and this is going to be useful for when we are shooting and needing to actually detect, have we hit a player. Next, let's also add in a new layer right here, and I'm going to call this one player. Now, the reason why we have a player layer is because when we have multiple players, we want them to be able to go through each other. Go yes, change children like so. And the reason why we want them to go through each other is because if they're colliding and bumping into each other, it may be a bit annoying if you're trying to just walk around and you keep bumping into players, so being able to walk through them is going to be just fine. Now, to make them actually walk through each other, we need to go up to Edit, Project Settings, and inside of Project Settings here, let's go over to Physics 2D, and down here you'll see we have a sort of little matrix here of our layers. Now, we want to look where the player at the horizontal and vertical axes align, okay, so right here, and disable that. So as you can see, player-player interactions will not be collided with each other, okay, so they'll just be able to walk right through each other. Exit out of that, and let's start working on our components. So first of all, our capsule collider looks pretty good. It matches the player pretty well, so we can just leave it as is. For our rigid body 2D component though, we need to modify a few things. First of all, let's go down to Constraints and click on Freeze Rotation on the Z-axis. This is going to prevent our player from rotating like this if they fall off a platform or land a bit weird, so we always want to keep our player upright. And apart from that, everything else can be set as is except for the gravity scale. I'm going to make that 1.5 because by default, gravity at just 1, seems a bit floaty. Okay, we want our players to be able to fall down pretty quick and then jump back up in the air. So we've got that all set up. Now, next up, we need to create an empty object as a child of player here. And this is going to be our muzzle, okay? This is going to be where our projectiles are being spawned from. So what we want to do with our muzzle is select it right here, and I'm going to set the position to be 0.36 on the X and -0.1 on the Y. So it's just in front of the player's weapon right here. So this is where we're going to be spawning our projectiles and then shooting them outwards like so. Alright, so that is our player object setup. Now we just need to attach a few more components. The first one is going to be a player input component, and this is a component that comes with the player input manager, or the new input system I mean. And in here is where we can define an action map for the player to be using. Okay, so I'm going to click on this little circle here, select the input actions action map, which we created in the previous lesson. It's now assigned right here. And then what we need to do is go down to where we have behavior. And we want to change that from send messages to invoke Unity events. And if we open up this events dropdown, open up main, you'll see we have an attack, a jump, and a move event. And what this means is that we can create a script which then listens to these events. So basically, whenever we press the attack, jump, or move button, those can each call their respective function in our script. And then we can move, attack, or jump when those are detected. So we've got all that set up. Now, what about the actual script that is going to be controlling the player? Well, for that, we can go over to our scripts folder and create a brand new C# script called player controller. Okay, and then we can go ahead, select our player once again, and attach this script just like so. Okay, so we've got that all set up. We've got our player right here. Now, finally, what we need to do is go to our prefabs folder and drag the player in to save them like so. And there we go. So now we have our player saved, and we are ready to begin scripting. But first of all, let's check to see if our colliders actually work. So in the game view, I'm going to press play, and we should see that our player falls to the ground and lands on the platform like so, which is good. Okay, if they do fall through, make sure to add a tile map collider to your actual tile map here, or make sure to adjust the player's collider. Now you'll see that we're getting an error right here in the console. And the reason why is because when we created our background canvas, it also created an event system. Now, an event system is used to basically detect inputs from the UI's buttons and various other interactable elements. And on our event system component right here, you'll see we have the standard input module component. And this is basically got a big error telling us that this no longer works because we have a new input system added. Now, to fix this issue, just click replace with input system UI input module. That's going to update it to a more recent version, which interacts with the new input system. And there you go. Clear that console, press play again, and you should see no more errors. Okay, so we're good to go, and we are good to begin actually creating our player's code. So that's what we're going to do in the next lesson. We'll be setting it up so our player can move, jump, attack, and all that good stuff. So thanks for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to begin scripting our player, okay, giving them movement, jumping, attacking, all that player logic that we need to set up for our game. So let's open up our player controller script right here inside of Visual Studio, and we can begin. Okay, so here we are. I'm going to go ahead and delete the start and update function since we don't need them just yet, and we have a blank class. So to begin, let's create our variables. Okay, now we're going to have a few variables. First of all, we need a public int for our current HP, so public int cur HP. This is going to be how much health we currently have. We then need one for our max HP, so when the player respawns, what is their HP going to be set to? We need a public int for their score, so whenever they kill another player, their score will go up. We then need a public float for the move speed, a public float for the jump force, and a public float for the max jumps, okay? Or a public int for the max jumps. Now, what max jumps basically means here is how many times can we jump without touching the ground? Because in many fighting games, you can either double or even triple jump in these sort of games. If you've played Super Smash Bros, you can jump quite a few times before touching the ground again. So that's what we're going to implement as well. And as well as max jumps, we also need to keep track of how many jumps we have available to us, okay? Because whenever we jump, we need a way of detecting, okay, the player's jumped, so they have 1 jump left, 0 jumps left, they can no longer jump anymore. So I'm going to create a private int called jumps available. Alright, just like so. Now next up, we need to create a header here, and this is going to do with our components, okay? All of the components we need access to, such as a public rigid body 2D for our rigid body. I'm just going to call that ridge. We then need a public animator for our animator component, which we're going to be adding in a later lesson. I'm going to call that one anim. We need a public transform for our muzzle, and this is going to be where we spawn our projectiles from. Okay, now we have everything there set up pretty much. One more thing we need to do is add in another private float variable for our current movement input, okay? Now, current move input, this is basically going to store that float value from our move action, okay? -1 if we're moving left, 0 if we're standing still, and +1 if we're moving right, okay? So we can then use that value to move our rigid body around. So what we're going to do now is go down into the fixed update function, okay? Void fixed update. And fixed update is a built-in function to Unity which gets called every 0.02 times a second. It is basically similar to the update function, although it is being called a set number of times per frame. And the reason why is because when working with physics in Unity, it's generally good to have this at a fixed time step just to allow for more predictability. So in fixed update, we're going to be calling all of our physics related things basically, okay? So first of all, we need to be moving around. So I'm going to create a new void move function right here, which we can then call in fixed update. So every frame, we're going to call the move function like so. And down here in move, what we're going to do is set our rigid body's velocity to basically move at whatever the current movement input is. So ridge.velocity, which is a vector that is our movement and direction per second. So we're going to equals new vector 2. Now for the x, this is our left and right movement, so we want to have our current movement input, and we want to multiply that by our move speed, okay, so we can vary how fast we move. And for our vertical velocity, we are just going to keep this at whatever it is right now, so we can go ridge.velocity.y. Okay, because if we're falling, we don't want to modify or mess with it right here. That will be over in like the jumping code, for example. Now, let's go and do the jump function now. So void jump right here. And this gets called, of course, whenever we press the jump button and we have the ability to jump, okay? If we press the jump button and we don't have any more jumps available, this isn't going to be called. But if it is called, then what we're going to do is, first of all, stop our vertical velocity, okay? So if we're falling, for example, we want to basically freeze our velocity mid-air and then jump on top of that. So I'm going to go ridge.velocity equals new vector 2. Our x is going to be, whatever it is, since we can be moving and jumping. So ridge.velocity.x, but our y is going to be 0. Then what we're going to do is add force upwards. So we're going to go ridge.velocity, not ridge.velocity, ridge.add force. We want to add force upwards, so we can go vector 2.up, multiply that by our jump force, go comma, and then the second parameter is going to be a force mode 2D. And this basically defines how we want to add force. Do we want to add it gradually, like we're pushing a large object, or do we want to make an impulse, like we are hitting a baseball? Okay, we're going to go impulse, since jumping should really be an instant momentum change. And then off with a semicolon, and that is our jump function done. So we've got these things here. Now what we need to do is basically connect these to our inputs. We've got our input map, we've got our input actions. How do we connect these to our script? Well, to do that, we need to go to the top here and add in the using Unity engine.input system library, so we can access that like so. Go down and we're going to create a few functions, okay? So in order to basically connect an input action to a function, we need to basically have a certain parameter, okay? And I'm going to do that just now. Let's go public void on move input. It doesn't really matter what you call the function. What matters is the parameter right here, which is going to be input action dot callback context, and I'm just going to call this one context. So this callback context basically contains all of the information that we possibly need to know about this input, okay? Is this the first frame it's been pressed? Is it being released? Is it being held down? What is the float value? What is the vector value, the int value, the bool value, etc.? All the information that we'll possibly need to know about this certain action gets given to us through this parameter. Let's create two more, one for the on jump inputs. Okay, so we got those three functions right there. Let's start with our on move input function, okay? So basically, whenever this gets called, that means that we are pressing down one of the movement keys. So what we need to do is set our current movement input value. So we're gonna go car movement input equals context.read value. Read value basically reads a certain value we wish. For that, we're gonna have float. And this is basically going to get the float value, which is going to be a range between -1 and 1, and assign that to our current movement input variable, which we then use in order to move our player left and right. Okay, pretty simple for that one. Now, when it comes to jumping, this is where we actually need to create a separate function to detect if we are grounded, okay? So in the onJump input, what we're going to do is check to see if this is the first frame that this button has been pressed down, okay? Because we don't want to jump every single frame that we are holding down this button, okay? So to check that, we can go if context.phase equals input action phase dot performed, okay? And this basically means the first frame that this input is pressed down. So if that's the case, we then need to see, okay, do we have any jumps available? So if jumps available is greater than 0, so if there are jumps we can do, then we are going to first of all subtract our jumps available by 1 and call the jump function, like so. Okay, and that is the onJump input function right there. So That is all we're going to do for this lesson. In the next lesson, we're going to set it up so that we can detect when we are touching the ground and then basically reset our jumps so that we can jump up and down, hit the ground, and, perform how we wish. And then we're going to connect these functions to the player input component so we can actually see it in action. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to continue on with scripting our player controller right here. In the previous lessons, we set up our input functions, so for detecting when we have pressed the move input, the jump input, or the attack input. For the move input, we are basically setting our current movement input variable, which we are then using to basically move our player around here in the move function. And for the on jump input function, we're checking to see, okay, is this the first frame that this button has been pressed down? If so, do we have any jumps available? And if so, then call the jump function, which basically adds force to the player upwards. So to begin, we are going to be creating the on collision enter 2D function. Okay, down here, void on collision enter 2D. This basically gets called whenever we collide with another 2D collider. Okay, and it has a parameter of basically the collision information. So what we want to check to see is if we have collided with this object that is below us, okay? Because if we collide with an object with our head, for example, that doesn't mean we're standing on the ground. But if the object we are colliding with, if the collision point was below our waist, then, most of the time that means we are standing on the ground or standing on some solid surface. So to check that, we can go if collision.contacts. Contacts is basically all the contact points that this collider has connected with another. It's an array, so we're just going to get the first element by going 0.point.y. If the y position is less than our y position, then it's below us. So transform.position.y. And if that's the case, then what we're going to do is just go jumps available equals max jumps. All right, just like so. That's all we need to do in order to reset our jumps. So now that we have that set up, let's go ahead and actually connect up these two functions, and this one down here, to our actual player input component so we can start detecting these inputs when playing the game. All right, so save the script. Let's go back into the Unity editor right here. Let's select our player prefab, or not our player prefab, but our player game object in our scene. I'm going to go down to where we have the player input function, open up events, open up main, and I'm going to add a new listener to attack, jump, and move. Now, for this, we need to drag in our player object like so into the object field. And the function, we click on no function, we go over to where it has player controller on move input. So just select the relevant function for whatever event is being called, so on jump input. And finally, we have attack, so player controller on attack input. So now we have connected our actions here to their respective functions in our script. Now finally, let's just connect everything up to our player controller script right here, and we should actually be able to then move our player around. So first of all, let's just start by attaching our actual components. So for that, I'm going to drag in the rigid body here. I'm going to drag in our muzzle here for the muzzle. Animator, we can leave as is for now. Current health, I'm going to set that to 3 as well as 3 for the max. Score, we're going to set as 0. Move speed is going to be 4. Jump force is going to be 10. And max jumps is, let's just say 2. Okay, so we can jump twice in the air before needing to touch down again. Let's press play and see if it works. So here I am on controller. I'm moving left and right. I can press up arrow to jump, and I can jump twice before having to touch the ground again. Okay, 1, 2, no more. When I touch the ground, I can then jump twice again. Okay, which is pretty cool. So we got this all working. Now, a few things with our player controller is, as you can see, if I try and sort of go onto the side of a platform here, let's try this out, you'll see I get stuck, okay? If I jump and I move into a platform, I'll get stuck, and I'm basically not able to move until I stop pressing the right arrow key to fall down again. Now, that may seem not like a big issue, but when you're playing a game where, you're trying to dodge projectiles and get around players, getting stuck like this, it isn't that fun. So how do we fix this? Well, first of all, what is the reason why this is happening? Well, the reason why is because all rigid bodies and Unity physics components have a certain amount of friction, okay? And when two objects are colliding with each other, even if they're both vertical, there is still friction that is being applied that is preventing one from slipping away from the other. So what we need to do is create something known as a physics material, which we can apply to our player and our tile maps. So let's go over to the other folder. I'm going to right click, go create 2D, physics material 2D. I'm going to call this one our player. And you'll see here by default friction is 0.4. Now we're going to reset that and change it over to 0. So there is now 0 friction between the player and their environment. So I'm going to select the player here, go down to the rigid body 2D component, drag in that physics material to the property right here, and let's select our tile map and do the same thing for the tile map collider 2D. Okay, so now both these objects have 0 friction. So if we press play again and try and get stuck just like we done before, you'll see it doesn't work. Okay, I'm trying to move into the platform, but I'm just slipping out of it, and we can then basically move fluidly through our level now, which is really nice. Okay, so there we go. We've got our player controller moving. Now let's have a look at the minor things that we need to fix. First of all, our player isn't rotating whenever we move left, okay? They're facing the wrong direction. So how do we make our player flip their direction when we are moving left or moving right? Now to do this, what we're going to do is just go to our fixed update function here, and underneath what we're going to do is go if current move input doesn't equal 0. So if we are currently moving in either the left or right direction, then we want to change our scale. So I'm going to go transform.local scale equals new vector 3. Now the X value is going to be whether we're looking left or right. By default, our local scale is set to 1, 1, 1. Now if our X is 1, we're facing right, and if our X is -1, that means we are flipping the player horizontally, so we'll then be looking left. So if our current movement input is more than 0, set it to 1, but if it's less than 0, set it to -1. And for that, we can do a ternary operator right here by going cur move input is greater than 0, question mark. If so, make it 1, colon, which is sort of like or, we can make it -1. And for the Y, that's going to be 1, and for the Z, that's going to be 1 as well. So this line of code right here should be able to flip our sprite or our player object left and right, depending on if we are moving left or right. Now, the reason why we aren't flipping the sprite right here is because we also have our muzzle, which is attached to our player's face and direction, so it will be a bit more confusing and a bit more code to set that up. So just flipping over the scale is easy enough, okay? But if this was going to be a more complex player controller, you probably would want to flip the sprite individually and not the whole player object. Alright, so now that we have done that, in the next lesson, we are going to be looking at actually spawning in multiple players with multiple controller devices. Okay, pretty exciting stuff, so I'll see you all then.